Hello everyone, welcome to ZaranTech. In today's digital era, mastering programming languages like ABAP is essential for unlocking the full potential of SAP systems. Today, we're diving into the realm of SAP ABAP programming and SAP ABAP on HANA. Let's break it down. SAP ABAP is a high-level programming language created by SAP for building business applications. SAP ABAP on HANA takes this to the next level by integrating with SAP HANA, the revolutionary in-memory database platform. Together, they form a powerhouse duo driving innovation and efficiency in the business world. SAP systems are vital for many organizations, managing key functions like finance and HR. With over 440,000 customers globally, SAP is crucial for businesses. As digital transformation continues, skilled SAP professionals are in high demand. Learning SAP ABAP and ABAP on HANA isn't just about coding, it's about enabling businesses to excel in the digital era. Mastering these skills enables you to enhance processes and drive growth for your organization. In this course, you'll master SAP ABAP programming and ABAP on HANA, from syntax basics to advanced HANA utilization. Each lesson enhances your skills, building a comprehensive understanding of enterprise tech. But before we begin, please subscribe to our YouTube channel and hit the bell icon to receive regular updates from us. Now let us take a look at the agenda. Agenda 1. Introduction to SAP HANA Studio. 2. SAP HANA and ABAP Evolution. 3. Secondary database connections. 4. Understand the SQL Monitor (SQLM). 5. Performance guidelines for ABAP on SAP HANA. Let's dive in.
Right. So today we'll talk about an important topic, which is the tool what we use when we start working on this HANA, right? So which is a HANA Studio. So yesterday we talked about what is SAP HANA, right? We talked about what are the different things HANA can do and what is its architecture and how the server is configured or adjusted in terms of internally, right? So these are the things what we have discussed, right? Today we'll be talking about a topic called modeling, HANA modeling, right? So what is a HANA modeling means, right? So modeling in HANA is like if you want to showcase a data from a business perspective, right, to a end user. So how we can show the data? So we need to show the data to the business users via a model, a data model we call it as, right? So that model is finally utilized either by a report or a program, and finally it reaches out to the end user, right, and business user. We can create a data model or a view with this particular business logic, right? So, and when that particular model, what we have built on top of the data will be used in various applications, right? You can assume that particular model in ABAP or in BW or any third-party applications. So the SAP HANA Modeler option is mainly used to create information views on top of schemas, right? So we'll talk about what is information view, what is schema in the coming slides. But just to understand, this particular HANA Modeler option is actually used to create information views on top of HANA, right? HANA modeling is done on top of tables. So when I say tables, those are all the SAP tables, right? So similarly, how we have tables, the core database tables in ERP, we have the same tables existing on top of HANA as well, right? So we do the modeling on top of those core tables, which are available in the catalog tab. We will be having a folder or a tab called catalog, right? When you log into the HANA Studio, you should be able to see it, right? And whatever the views we create in terms of this data model, they're all saved under the content table, under a package, right? So what are the different features what we have from this particular HANA modeler, right? HANA information model. So users can create information views, right? Mainly in the columnar store, or the columnar tables in the database. Because to get the grasp of and the experience of HANA, right? So we definitely need to use the columnar table most of the time, until and unless you have a specific condition where you cannot use that particular column table, then only we generally go for row tables. But as my experience, I have worked around 5+ HANA implementation projects, like the 4+ HANA implementation projects of 5. So out of all the things, we never used a row table when we start modeling a information views, right? Most of the time we use the columnar tables only. A user can create multiple views using the data from the tables what we have on top of HANA databases. Okay. So similarly, if you take the traditional ERP, right? So we have the core SAP tables which will be sitting on top of any other DB, right? So if you want to create a view, you can obviously create multiple views on top of the data. Similarly, the same scenario falls good for HANA as well. So we have few analytical tools which we can use, right, to understand or to showcase the data aspect of from our information view, whatever we'll be building, right? So those tools are like SAP Lumira we have, and you can also build a custom application out of this information view or data model using Fiori or any HTML application also, right? So you can use however you want based on your use case. Once you have that information model based on your use case, you can take whatever the path you want to do, right? We can also utilize information views in MS Excel, right, which is connected for reporting SAP HANA. But most of the time, as now we have a different set of technologies where we can consume this information models and display a good report to the business users, right? So no one is nowadays actually looking at this MS Excel integration, but if you user is asking for an MS Excel integration with HANA, and if you want to view the data model or the information view in Excel, yes, we can do that one as well, right? So simply we can say this HANA information model is like a powerhouse of SAP HANA, because with the help of this model only, we'll be able to get the data from the HANA database and we can showcase it back to the users, right? So these are all the different features what we have. Now, if we slowly go into the information views, right? So what are the different things we can see when you're talking about this information view, right? So we can talk about different things here, right? We are calling, sorry, okay. The information views, whatever we are calling, we can also call them as modeled views. So why we are calling this as model views? Because we are trying to create a model out of which we'll get the data from the particular data model or the information view, and we will finally give it back to the user in the form of a report or a program, right? So that information view is divided into 3 types, or we can say we have 3 types of information views. The first one is attribute view, the second one is analytical view, and the third one is calculation view. Okay. So we have 3 types of information views. The first one is attribute views, analytical views, and the calculation views. Now we will talk about attribute views, right? What are attributes, right? So attribute view acts like a dimension, right? So this is mainly used, right? So this particular attribute views, whatever we are talking in terms of information views, or acts like a dimensions, right? They join these multiple tables and they act as a master. So most of the time, if you are trying to deal with master data, we generally create attribute views. Okay, they are used to join dimension tables or other attribute views. So attribute views can be used, right? Attribute views can be used in analytical and calculation views for analysis to pass the master data, right? So whatever the attribute view you have built, right, for the master data, those can be consumed by analytical and calculation views to pass the master data, whatever we have brought in terms of this attribute view. Right? And these attribute views are reusable objects. So attribute views acts as a master data context, right? So which provides this text and descriptions, right? Let's say if you want to create an attribute view for the Mara table to get the material information, right? So we generally create an attribute view because from the material, we want the material number and the material description. Those are the key fields for us. So when you're trying to deal with master data, we generally go for creating this attribute views, right? So attribute view is also used to select the subset of these columns and rows from a database table. If you want to pull some data from the database based on a query, you can do that via attribute views. Okay. We'll be having a few options called measures and aggregations, which we'll be talking about in the next slides. But there is no feasibility, right, to create those measures and aggregations on top of this attribute view. So just keep these two words in mind. So when we come into that particular side, we'll be knowing more about it. Okay. So these attribute views are also divided into three types, right? The first one is a standard attribute view, derived attribute view, and timed attribute view. So what is a standard attribute view, right? So it is a standard attribute view which is actually created as a table fields. So we will not do much changes of it. So let's say if you want to consume a Mara table, and by consuming this Mara table, you want to create a attribute view out of it, right? So in this cases, what we do is you just consume that Mara table inside your attribute view, and you just push or show the data to the end user. We are not at all doing any changes to the particular attribute view. So that one, we call it as a standard attribute view, right? So the next one, what we have is a derived attribute view. So it is an attribute view which is derived from another existing attribute view. So it's like, you can call it as like an extension, okay? So derived view or the derived attribute view, whatever you have just derived it from the another attribute view, will be opened only in read-only mode, right? So you cannot do any modification in terms of fields or anything in the derived attribute view, right? In derived attribute view, we have an option called copy from. So just in case if you want to do a copy of your attribute view, you can simply copy that existing attribute view using that particular option, copy from. So standard view you generally use when you want to directly access the standard database tables or the custom data tables, but you will not be able to export it, right? It's like we are just using the table fields which are already created. Whereas the derived attribute view is the one which we use using an existing attribute view, right? And this will be always in the read-only mode. We have a third attribute view type called time attribute view or time attribute view, call it, right? This is based on the default timetable. So we have default timetables already set up by SAP in the SAP HANA server, right? If we are using those default timetables and trying to create an attribute view, we call that particular attribute view as time attribute view, right? So we have different time related parameters called time dimension year, and we have also one for week, month. So you can use all those relevant measures and try to create a time attribute view. Okay? These are the different types of attribute views what we have. So what we will do is we'll first complete the theory, and then we'll start to see how we can create these views in HANA Studio. Okay? So the next attribute view, the next view what we'll be talking about is a analytic view. Okay. So the next view, what we'll be talking is a analytic view. So analytic view is in the form of a star schema, right? So when we are talking about analytic view, we are talking all about the transactional values, right? So if you want to take care of this transactional data, we generally create these analytic views. And if you want also to do some analytics on top of it, right? If you want to perform few complex calculations, let's say we have a humongous data and you want to get what is the total gross amount for a particular region or a country, right? So to do that, you generally use a function, some function, which we call as aggregate functions in HANA. And this analytical view will be generally in the form of a star schema. So why we are calling it a star schema? Because we deal or we combine the combination of dimension tables, right, attribute views, right, and the master table. So with this combination, we try to create a analytical view, right? So that's why it will be in the shape of a star, right? So we call that particular analytical view as a star schema, right? So we'll combine different sets of dimension tables with the transaction table, whatever we'll be creating, and it will be in the form of a star. That's why we call this particular analytical view as a star schema. Okay, and yeah, so this is if you have idea on BIBW, right? So this is similar to the info objects and info sets what we used to create in the BW, right? So whatever the model you create in BW as well, similarly, once the model is created, right, on top of it, you create these info objects and info sets for cubes and all, right? So this particular analytical view is also similar to that. The third one, what we have is a calculation view. So calculation view is used to consume other analytic attribute and other calculation views. Okay. So the main advantage of this calculation view is if you are trying to create a calculation view, what you can do is inside that particular calculation view, you can consume another analytical view, you can consume attribute view inside it, and you also can consume other calculation views inside it as well. So this particular calculation view is built mainly when you want to perform complex calculations which are not possible with other views. So this calculation view gives a few add-ons to do the complex calculations which are not possible in terms of this analytical view. So in that case, we generally go for this calculation views, right? So there are two ways to create this particular calculation views. So either you can create via SQL editor, or you can also do it with a graphical editor. These are the two ways which we can follow and try to create a calculation view. And inside this calculation view, right? So whenever we are using this calculation views and all this stuff, right? So we have something called a scenario panel inside the editor, right? So what does that scenario panel will have? So that scenario panel will actually give us a projection, right? A projection to different types of nodes. So what are the different nodes this particular scenario panel will be having inside the calculation view? We'll having a node called join. We'll have a node called union. We'll have something called projection. We'll have aggregation, and we'll have a rank, right? So what is the use of this join, or when we generally use this particular join from the scenario panel, right? So this particular join is mainly used, or this particular join feature is mainly used to join two objects, right? To join the objects A and B and pass the outcome of that result to C. That's where we use this particular feature of join, right? So you, as you are aware of this ABAP, right? So this is like a join what we used to write. So this join, if you go inside it, So these join types can be inner join, left outer join, right outer join, text join, right? This is also a join what we used to use, but here they have placed it inside the calculation view. And the next one what we have is union, right? So union is used to perform, right? Union operation, like we have an object A, we have an object B, and if you want to get the data of both the objects A and B, and you want to show it in C, right? In that case, we generally do a union. So this union operation is performed when you want to get all the data from both the sets, right, or from multiple sources and display it to the final source, right? You can have a number of sources. You just do a union on top of the sources or the tables, and finally push that output result to the next item. So the final result will be displayed in the object C. We have the next one we talk about is a projection. So what is the use of this projection? This is mainly used to select columns. Okay, so we will be creating few fields inside this aggregation, sorry, inside this information views, and we'll be selecting columns to the final information view, right? So this is mainly used to select those columns, and if you want to do a filter on the data, right, and if you want to create any additional columns, right? So in those scenarios, we generally use this projection. Aggregation is used to perform the aggregation steps on a specific column based on the selected attribute. So when I say aggregation, it is nothing but using or trying to do a sum, trying to get the count of all the records, or trying to get the average of all the gross amounts. So, right, all these aggregation concepts come and fall under this particular category. And the rank is the exact replacement of the rank function what we have in SQL, right? So if you have a bit of idea in SQL, we have a rank function SQL as well, right? We can simply define the partition, right? And we can also do the order by based on the use case, right? So just to do that particular part, we generally go and create the ranks. But most of the time, we generally use joins, unions, aggregations. Sometimes we use projections as well. So these are the mainly used scenario panels in terms of calculations. But we mostly use this joins, unions. The next one, what we have is called a catalog, right? We have catalog and a schema. We can consider this as two different things, okay? So whatever the catalog we are talking about, so you can consider that catalog, right, as the objects what we use to place, right? Catalog is like a container where we place all our design time objects, okay? So whatever the design times objects we are trying to do, we'll be placing that inside the catalogs, okay? You can consider that as a catalog. The catalog divides the database into sub-databases, right? So we call them as schemas, right? So whatever what you call the division, what we are doing in terms of data catalogs, we call each and every entity as a schema. Okay, schema you can simply consider as a container of all the database objects, right? Okay, the runtime object, database object. So it is the, you can consider it as it is the home of all the database objects like tables, structures, procedures, everything, right? In SAP HANA, we can see all those schemas in the catalog section. Just to iterate, right? So schema is a container of all the database objects, right? So what are the database objects you create, like tables, structures, procedures? We store all those database objects inside a schema. And you can see all the schemas in the catalog section. So database schema enables us to logically group all these tables, views, stored blocks, structures, everything into a group. So without a defined schema, we cannot write to the catalog. So let's say if you don't have, you created some G object, and you will not be able to write that Z object into the catalog if you don't have a defined schema attached to it. So in the next steps, we'll see how we can create that schema and how we can place those objects inside the schema. Okay? So whatever the schema you are trying to generate, right? Once the schema is created, right, then you will be able to create your objects and place your objects inside that schema. So whatever the data objects you will be trying to getting, they are all attached to the particular database schema. And we have, or we can divide the schema, right, into three types. So first we'll talk about a generic or a generalized schema. Okay, this schema type, whatever we are discussing, is related to the data warehousing concept. Okay, so in terms of that particular definition, we can divide these schemas into three types. First one is a star schema, the second one is a snowflake schema, and the third one is a galaxy schema. So what is a star schema? So in star schema, each dimension is joined to one fact table or a transactional data table, what we have discussed, right? So each dimension is like one master data, right? And whatever the fact table what we have created, whatever the transaction table what we have created, those will be considered here as a fact table. You can call either fact table, which internally has all the transaction data. And whatever the master data we have, we call them as a dimension tables, right? Or the dimensions. So each dimension table is connected to a fact table, and fact table will be the primary key for all those dimension tables. So as I said earlier, in the middle, in the center, we'll have a fact table, and at the four corners, we can put as a dimension tables, different dimension tables. And if you try to do a shape of that, it will be in the form of a star. That's why we call that particular schema as a star schema, right? So dimension tables contains the set of attributes that are used to analyze the data. The next schema what we have is a snowflake schema. In snowflake schema, some of the dimension tables are normalized, right? And those dimension tables are connected to a single fact table, right? So the structure remains similar to the star schema, but here few dimension tables are normalized. So normalized means we generally break a table into small tables. So if you have a large table which has lots and lots amount of data, so we generally do a normalization on top of it, right? So we generally break the table into smaller parts without losing any information or data inside it. And those smaller tables are again joined to the dimension table. And that one we call it as a snowflake schema. And the third one we have is a galaxy schema. So galaxy schema, there will be multiple fact tables and dimension tables. So if you consider we have only one fact table when talking about star schema and snowflake schema. But when we are talking about galaxy schema, there will be a multiple fact tables and dimension tables, right? And for each fact table, there will be a multiple dimension tables which are attached to it. That's what a galaxy schema is. Now, when we talk about different types of schemas from a HANA database perspective, we have three types of schemas, right? The first one is a user-defined schema. So these schemas are created by the database users or the admins, right? So all the schemas, whatever we create, will fall under the catalog tab. We have a next schema called system-defined schema. So these schemas are generated by the HANA functions, right? So some of the few types of system-defined table schemas are, we have underscore sys underscore bi, we have underscore sys underscore big, and etc. So these are the system schemas. So whatever the objects which are relevant or linked to that system will be stored in that particular schema. And we have a third schema called SLT derived schema. This is mainly generated as part of the SLT data replication in HANA. So we can just try to understand the user-defined schema and the system-defined schema as part of this course. And once we get hold of the system, we'll try to see how we can create and activate a schema, how we can create different sets of views, like how we can create an attribute view, how we can create an analytical view, and how we can create a calculation view as well, right? We have one more concept called SAP HANA Live. Okay, so this one will just try to understand it. Will not be touch basing more about this here because it is not relevant to ABAP and HANA. But I just want to give you a quick pointers on this one. So we used to call this SAP HANA Live as SAP HANA Analytic Foundation. So now they are calling it as SAP HANA Live. So this is like a solution for a real-time reporting on top of HANA. Okay. So it represents a pre-built views, or it provides the SAP delivered content, right, in the form of a SAP HANA calculation views, which we can directly use for real-time operational reporting. So there is no need for you to again go and build a custom information view and try to create a report out of that particular view. There is no need for that. So SAP HANA Live gives a predefined content, right, in the form of a calculation views, which you can consume and use it for a real-time operational reporting. So the views are based on the standard transactional tables that can either be replicated from the operational system or used directly in the operational system. So these particular built-in views or the predefined views, what we are talking here, are not available for SAP ERP systems. Okay, and these are mainly for HANA systems, and it gives you the feasibility to do this real-time operational reporting purposes. And this also, the calculation views, whatever SAP Live is provided to us, spans across most of the modules. I'll not say all the modules, but it spans across most of the ECC modules, what most of the business users used to use, right? So we have this calculation views built in SAP HANA Live for FICO, MM, PD, CRM, GTS, GRC, all this stuff. So whatever the content they are providing to us is represented as a VDM model, VDM scenario, which we call as a virtual data model. So this is mainly based on the transactional and the master data tables of the SAP Business Suite. So VDM is not a language or a technology. It is just a good standard or a gold standard what SAP is using when trying to build these views. Okay, so VDM is just a standard used by SAP when creating these views. They call that particular data model as a virtual data model, which is mainly based on the transactional and the master data tables of the backend systems. So what is the main difference between these two? So what is the main difference, or why SAP has brought in this SAP HANA Live? Because we already have a BABW systems in place, right? So if you try to see this particular slide, right here, we are trying to showcase the difference between the traditional BI and the SAP HANA Live. So to the left side in the blue color, right? So these are the steps what we generally do in the traditional BI systems, right? We generally do a transaction with the data. So what are the transactions we do? We transact with those systems, get the data, and inside the BW, we analyze it, and then we try to accelerate it, right? And finally display it to the user. But in the HANA Live, because of the capability of this in-memory what we have on top of HANA servers, we are doing the transactions and analysis directly on the memory using the HANA features. Got it, right? So with the introduction of HANA, we can do the transactions along with the analysis directly in the SAP HANA memory itself, and that too real time. That's why we are calling that as a HANA Live. So whatever the transactions you are doing on top of SAP HANA, you can, at the same time, you can also do the analysis as well on the particular transactions, what you are performing on top of the SAP HANA server. So that's the main difference what we have. There is no need for you to schedule your back job. get the data, and then do the analysis, right? You can, whenever the transactions gets updated in HANA server, immediately the data gets live and you can start doing your analysis on top of it. It's like a plug and play, right? Yeah, so this is how it will look like. So the top part is all about the applications, what all will be accessing with this HANA Live. But inside this, you can see, right? So we have something called VDM, which I told you, virtual data model. This is the box which is important to us. This is the HANA Live box. Okay. Inside the HANA Live, we'll have something called a virtual data model, which actually tells us the standards of how SAP has designed this particular views, right? And you'll be able to use those calculation views, which are already defined by SAP, right? Along with that, you can also create your own personalized views, and you can also add some extensions on top of it to fit your business scenarios, right? And this is how it will look like. So this is similar to the previous slide, but in a more stringent format, right? So the top we have front end, we have a business suite, and the bottom we have a HANA system, HANA server. On top of it, we have put in the HANA Live components, right? This HANA Live components can be accessed by any application. So this HANA Live can be accessed by Bob J system. It can be accessed by your Fiori system. It can also be accessed if you have any React application, and if you want to get the data from the HANA Live system, that one also you can do. It's like an integrated stack where you can get the data from the HANA Live system and you can display it to the end users. So now in this particular topic, we will talk about ABAP and HANA. So because till in the last couple of sessions, right? So what we are talking about is all around SAP HANA, what we can do, what is HANA, what HANA will be doing on top of HANA, what we can do, right? So now we'll try to see what we can do using ABAP on top of HANA. We'll see the SAP HANA and ABAP Evolution, right? And we'll also try to identify the HANA specific settings in ABAP dictionary. So what new settings HANA has brought in terms of ABAP. And we will also see an important topic, which is the code to data concepts. This is the main crux for this ABAP on HANA. Okay, right. So first we'll discuss about the evolution of ABAP programming. Okay, if you see this particular slide, right? So initially what they have done is, so they have brought in just the HANA DB. So initially they did not, SAP did not roll out a brand HANA system to the business users or their customers. What they did was they just given an option to their customers saying that, hey, we have brought in a new database called HANA database, and if you want to use it, you can use it. What you can do is, what they have suggested, simply what I can say is, what they have suggested is, SAP is, so you can use your traditional database. Along with that, you can add in this HANA database, right, as a side scenario. Along with that primary database, whatever we have, you can use this HANA database as a secondary database, and you can start using it and provide as a feedback. That's how SAP has brought in this HANA database to its customers, right? So the customers who has agreed to use that particular concept or agree to use HANA database as a secondary database, what they can do is, now their ABAP system can access SAP HANA, right? In this particular side-by-side scenario. Let's say if they are trying to write a new program, what SAP has suggested is, instead of doing a query to your traditional ERP system, try to do a query to the HANA DB. When they followed that particular approach, they see an enormous amount of improvement in the performance of the report when trying to access the data. That's the main fetching point what SAP HANA has brought into their customers in the side-by-side car scenario, right? From the next step, so once customers are happy and SAP got the feedback in the side-by-side scenario, what they have brought in is, from NetWeaver 7.31, right? From NetWeaver 7.31, ABAP can run on SAP HANA directly. So there is no need for you to maintain now HANA DB as secondary database. You can make HANA database as a primary database if you are on NetWeaver 7.31, right? And this can run on SAP HANA, and also they have brought in SAP BW on HANA as well. So these are the two things what they have brought in. And you can migrate or upgrade your database to HANA database only if your NetWeaver version is greater than or equal to 7.3. So once customers are using it and they got a good grasp of SAP HANA and they saw the improvements of the performance in terms of data retrieval, the real-time analytics, and the real-time results, SAP has further optimized the ABAP on SAP HANA, right? And made a primary database for AS ABAP HANA as well. So along with the HANA components, now what they have done is they have made and optimized this HANA model also to the ABAP servers from NetWeaver 7.40. So this is how the SAP HANA has evolution in terms of ABAP. So now if you see the latest version 7.5 and all, right? So there is no need for you to go to the SAP GUI screens to do your developments. If you want to create a function module, if you want to create a structure, if you want to create a report, there is no need for you to log into your SAP HANA system. They brought in the front-end tools. They call it as a Web ID tools, right? So using that tools, you can directly do everything inside the particular tool. There is no need for you to go here and there, right? We'll be seeing that soon. So what are the different things SAP has brought in when trying to use these SAP applications on top of SAP HANA? So the main and the most important thing is the optimizations, right? So they have optimized the hardware software, right? And along with that, they also provided a new development guidelines, which actually optimizes the existing code and gives you the full end-to-end improvement experience or the fast track experience of the SAP HANA in terms of the execution times. So they have the improved tools for performance analysis. So if you want to do some performance analysis for your ABAP applications or reports, we have few tools which we can use. And they have also brought in few extensions to the ABAP language. And we can also create and consume this SAP content HANA. Whatever the HANA content we are writing, we can use them in ABAP. Right? These are the different things they have brought in for optimizing the applications. So what are the common changes which will happen to the existing traditional SAP tables when we are changing our traditional or the primary database from Oracle or MS SQL to SAP HANA? So these three are the different things which will happen, right? So these three are the different things what will happen when you try to migrate or change your HANA system, right? Or HANA database from non-SAP database to a SAP HANA database. So the first and the important thing is the depooling and declustering. That's a common change. They have done some depooling and declustering around it. And they have also removed the concept of the secondary indexes. So they have deactivated the secondary indexes, and they have also emptied the, they have also brought in the aggregate tables as well, right? So these are the three things which we have. I think we can discuss in the, we have in the next slides. So what are also the new settings they have brought in ABAP dictionary to support this particular SAP HANA DB, right? So they have brought in different storage types for the tables. As I said, they have brought in this depooling. When I say depooling, they have totally removed those pool tables and the cluster tables. That's what they're calling it as depooling and declustering. So in SAP HANA, you can't see those pool tables and cluster tables. All those pool tables and the cluster tables are converted into the transparent tables or transaction tables only. And they have also removed almost the concept of the secondary indexes, okay? And they have brought in a full text index. They have brought in a new setting called, we can do a full text index. And we also have the setting for a table which we can set. when you're trying to store the data inside it. We call that type as a storage type. So if you see here, what is the storage type you can put? So when I say storage type, do you want a particular table, what you are creating should be the columnar store or a row store? That is the storage type what they're referring to. So if you see this particular screenshot, right? So this is the place where you need to go and see, or where you can go and see whether the table, whatever you are using, either it be standard or custom, is a column table or a row table. So just go to S11, open that particular table, click on the technical settings, and below you can see, if you click on this DB specific properties tab, right, you can see what type of storage type your database table is. Okay, based on that, you can easily identify the type of table what you are using. Right. So the new tab which they have introduced for this particular HANA is called a DB specific properties tab, which actually gives us the ability to switch between the storage types. Right. So if you select the storage type as column store, it creates the database table in SAP HANA column store. If you select the type as row store, it creates the database table in the HANA store. So once you create a custom table, you can just try to change the stores whenever you need, right? But as a best practice, once you create a table, because we create a table once we finalize all the prevalent properties and the implications what we have, right? So generally in real-time use cases, we never change a column store or a storage type. Sorry, we never change the storage type after it is created. As I said, declustering is also removed in terms of HANA, right? So how you can check that as well, right? So if you go to the table category of any table, right? So here in the below screenshot, you can see the table is a pool or cluster table or any DB. Okay, but it is changed to a transparent table in SAP database. So all these pool and cluster tables concept is totally removed, and now they have changed those tables to a transparent tables. They did not remove those tables, but they have converted all the pools and cluster tables to the transparent tables. So now you'll not be able to create any pool or cluster tables. If you want to create any table, it's just a transparent table, what you can create in the HANA database. And they have also removed the secondary indexes concept as well. So there is no need for you to create the secondary indexes from now on. Okay. So if you are an SAP HANA DB, there is no need to create a secondary index for your tables. You can see here in this particular table, this is a full text index what we will be doing. Okay, we call this as a full text index. We generally do this for the tables where we have a lot kinds of text for a material description, sales order description, right? So for those tables, we generally do a full text index. Okay, how we can see that? Just go to that again, click on indexes, and here, whatever the index you are trying to create for the text table is like once created, and you can make this particular index as a secondary index. And just to remember, we create secondary indexes only for the full text searches. Now we call that as a secondary index as a full text index because we do it only for the search capabilities of the text functions only. Right. So then what's in it for ABAP programmers, right? So because till now we are just ABAP technical developers. We used to work on all those reports, design, programming, and all the stuff, right? So once SAP HANA is brought into the landscape, right? And now they're talking about ABAP and HANA. So what is our part, right? So the main things what we can achieve is accelerate. So whatever the time our background job is taking, or whatever the time the report execution, the execution time what the report is taking, right? All those things can be accelerated now. So let's say you have built in a custom Z report. When you try to execute it, it used to take around, say, 5 minutes, right? If you try to execute the same report on top of HANA, I can definitely say the same report with the correct programming style will now take around 2 to 3 minutes. Got it? So that's what the acceleration this particular ABAP on HANA has brought in. Got it? And the next one, what we have is we can extend. So we can, instead of the background jobs, right? So let's say I have a report which is very complex and it contains a lot amount of data to be shown to the user. What we used to do is we used to put so many filters on top of it, and based on the user criteria, we used to show it. But now what we can do is the same application or the same amount of data can be now shown to the end user with more accuracy and with more improved performance, right? And once you create that ability, you can extend that particular application to more users, to more set of business users, because there is no, what do you call, the lagging time or the more pressure which is putting on the database nor the server, right? We can easily extend that particular heavy loaded application to more business users now. And we can also do a lot amount of innovation, right? So what are the new processes? You can also build new applications, because with this enhanced features, what we get, right? We have SAP HANA server, which is really fast. We have brought new standards for the ABAP, right? We have a new SQL syntax code. We have new code to data paradigm, with using all this concept, and we have also new improved UI UX, right? With all these improved features, what we can do is we can create new processes and applications and innovate and take our business users' expectations to the next level. Those are the things what we can achieve. Okay. So the next thing is, what are the different steps we need to take when you're trying to do a transition of ABAP code for SAP HANA? So let's say we have a lot of custom code on our existing SAP systems, and now our organization is planning to move from traditional ERP to HANA system, right? What are the different things we need to consider as an ABAPer? When the first and foremost thing is, what we think is what will happen to our ABAP code. So to counteract a particular problem, we can follow these three simple steps, right? The first one is detect. So we first detect by executing different performance measurements on our custom code, ABAP code, right? And try to prepare a report. Once the report is prepared, we'll try to analyze and prioritize the items inside that report. Once we identify that, the next step, what we do is we try to optimize the identified and the prioritized problems which are having the performance issues, right? We will use new features to optimize the existing code then. So once the optimization is done, then we innovate. So how do we innovate? So we use the new features, resources, and possibilities, whatever SAP HANA has brought in for ABAPers, and using all these concepts, we try to improve our execution level and the performance level of our application in terms of Z programs, right? These are the three steps we can follow to improve our ABAP code execution time when you are trying to do a transition from the traditional ERP to HANA system. So this is the new programming approach, what they have brought in. Okay, so if you do the left side, right, so we will talk about the middle part. So we have an application layer, we have a database layer, right? So first we'll talk about the classical approach or the traditional approach, what we are doing today, right? So the left side, you can see I have a report and I have written a select statement in my report. Select, say, start from a particular Mara table, or select a few 3 or 4 columns from the Mara table. Okay, I have wrote that particular report, and when I execute it, right, when I execute it, then the query will hit the database server, get the data, and then if I do any group by or sort by, right, order by, so all those additions or the filtrations will be done on top of application layer, and then the final result will be displayed to the user. Right. Similarly, if I'm doing any calculations, right, the same calculation what we have discussed. If I want to get the gross amount sum for a particular customer in that particular year, if I want to do that, I get the data from the database, I put it inside my application layer cache, right, in the transparent tables, then internal tables. Then I do all this logic. then I find the sum of the gross amount, and then I will display it. So in the classical approach, what we are trying to do is, we are trying to do the calculation, everything on the top of application layer. We are using database layer just to get the data and to store the data. But with the new programming approach, what they have done is they have flipped the calculation end. So what they have done is they have moved the calculations to happen at the database layer. Okay. So now, if you consider the same statement, same steps with the new programming approach, what will happen is, if I write the same, if I try to run the same report on top of SAP HANA, what will happen is, when I do a select statement, data will be fetched, and all the calculations, all the sum calculation to get the gross amount, right? Order by filter, everything will be done at the database layer. All this calculation will be done at the database layer, and then only the results will be transferred back to the application layer. That's where we are getting a big leap in the improvement of performance, because database is already, or we have a highly built up hardware which has multiple number of CPUs. We have multiple cores. The hardware is very good enough to handle all this stuff, and we also have the in-memory capability to do all these calculations, right? So because of that, the execution time has increased a lot in terms of getting the data, and finally only the results are pushed to the application layer. We are reducing the load of the application layer and finally displaying it to the user. So this is the new programming approach, what we will be following in terms of this ABAP on HANA. Right. Along with this new programming approach, we have also brought in the code to data paradigm. Right. So whatever the approach we have tried to understand here, it is simply the code to data paradigm. Right. Instead of doing all these calculations at the code level, we are trying to do everything at the data level. Right. In the code to data paradigm also, we have two sets of things, or we can say two approaches. We have two approaches. In traditional ABAP coding, right? So it's generally a standard practice to limit the number of hits to the database, right? By bringing data as much as possible. That's how we used to do, because we don't want our report to be running for long, right? So just in this particular bottom-up approach, right? So we should be having if you want to use this bottom-up approach, you should be on a product with ABAP 7.4, right? With 7.4, that's the minimum base version what you should have, right? So this is particularly a good concept, what you can say, right? This particular bottom-up approach, but it has few drawbacks, because the problem is the life cycle. Because what happens is, this HANA views, stored procedures, right? Whatever you are seeing these are created at the SAP HANA server level, right? This is created at the SAP HANA server level. So the main challenge for this particular bottom-up approach is its life cycle, right? So SAP HANA views, stored procedures are managed by the HANA lifecycle management system, right? They are living inside something called a delivery unit, which we generally use to transport it. So these are in terms of SAP HANA. But what happens is, so all these are interlinked. So if you're trying to do a transport, or if you are trying to consume this particular HANA view inside SAP ABAP view, right? So there is a direct linkage. So when you're trying to transport these development objects to the next environments, you should be careful that you transport the SAP HANA objects as well as your ABAP objects. If you miss any one of this in the process, you will see a dump in your next environment. That's the limitation what we have, and that's the drawback. We are calling it as a life cycle drawback. And the same holds good for the proxy objects as well. But you'll understand more when we try to discuss in hands-on, because we try to see what will happen when we try to create this HANA view, what will happen at the ABAP layer, what will happen at the HANA layer as well. Okay. And from the 7.4, right? So from the 7.4, they have brought in a new concept called top-down approach. So if you're an 7.4 SP05 greater than or equal to, you should be able to use this approach. So the top-down approach should be our usual way of working with the ABAP development objects. What does that mean? So what that means is, so we will develop HANA-based ABAP artifacts in the ABAP application server itself. So there is no need for you to again go back to your HANA Studio or HANA system. So if you take this two slides, so here we are trying to create a HANA view and then trying to consume it using native SQL. Right here, if you see, you're trying to create HANA view and trying to use it via external views. Right? We are referencing from the SAP HANA layer to the ABAP layer, but with the top-down approach, right? We are following a different concept. Now we will not directly interact with HANA layer at all. We'll be talking with SAP ABAP layer only. So that's where these AMDPs, ABAP managed data procedures, and CDS views comes into picture. So here what happens is, so once you create a CDS view and transport that CDS view to the next environment, the internal logic will be handled by the SAP server itself. There is no need for you to think about these life cycle challenges, what you may face. Got it? So that's the main difference what we have. So generally, how you follow the development process in the traditional system, right? So you create the report, capture the changes in the TR for that report, and release the TR, and it goes and sits in the QA system as per your transport policy, right? And when you try to run that report in the QA, it starts working, right? There is no challenges, whatever we have, right? Similarly, SAP has brought in this top-down approach for this ABAP on HANA as well, from 7.4 onwards. So with that, it follows the same process. Create a CDS view, capture it in the TR, push it to the QA, everything starts working. So the life cycle challenges has been well handled by SAP in this using this top-down approach. Okay, so this is the code to data capabilities what we have talked about, right? So yeah, so this is also the important slide what we need to say. So because if you see the performance improvement versus the codes adjustment graph, right? So whatever the optimizations we are doing, whatever the SQL advancements and the new features SAP has brought in terms of either CDS view or the AMDPs, right? So if we combine all these activities, right, along with the SAP native features, we can get a good amount of improvement in the performance of the execution time of your application or a report, right? We can use all these combinations to make your report or program run with a good execution time and also with a greater improvement in the performance aspect. Thank you, guys. So that's all on this slide. Tomorrow, what we'll try to do is we'll have a quick look at the ABAP HANA Studio features. Once that is done, we'll jump to the system. We'll see how ABAP HANA Studio ODT all looks like, and then we'll slowly start creating attribute view, calculation view, and analytical views and see how we can do that. Okay?
All right, let's test your knowledge. Here's a question for you. Which of the following is not a type of ABAP program? Option A, Module Pull Program. Option B, ABAP Objects Program. Option C, SQL Program. Option D, Java Program. Take a moment to think, and when you're ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck. Type the correct answer in the comment section. Hey there, ready to dive into the world of SAP ABAP programming and SAP ABAP on HANA? Our course is your ticket to mastering these crucial skills. Take it at your own pace right here on our platform. In this course, we'll unravel the mysteries of SAP ABAP. It's like having a super handy toolbox for planning and managing supplies, ensuring everything flows smoothly from production to delivery. We've got you covered from the basics to advanced techniques. Crafted by seasoned experts, this course is packed with knowledge you won't find anywhere else. Your instructors, top-notch pros with years of experience. They're here to guide you every step of the way and clear up any doubts you may have. But don't just take our word for it. Our students rave about how helpful this course is. People just like you have found immense value in what we offer. And the best part, it's incredibly affordable. This amazing opportunity to level up your skills won't break the bank. Ready to become a SAP ABAP wizard? Enroll now on our page. For more details, head over to ZaranTech's website.
So today we'll be discussing about a new tool called ABAP Development Tool. In short form, we call it as ADT. So this is an important tool what we use when you start working on ABAP on HANA. Okay, this tool is like what you call this is the place where we need to go if you want to develop or if you want to work on ABAP on HANA related projects. Okay, right. So we'll just try to understand what this tool is and how it is linked to different systems and how we'll start working on it, right? So if you see whatever the tool you're calling, right, the ABAP development tools, in short, we call it as ADT. So what SAP has done is, or how SAP has built this particular tool is, they have taken the base layer of Eclipse platform. So as you are aware, right? So there is a IDE called Eclipse, which is being mostly used by Java, .NET, so many other set of developers, right? But SAP have taken the particular base platform, Eclipse platform, and they have built few wrapper methods, classes, and they have created new IDEs, right? IDEs are the tools which we use for the front end and the back end development, right? They created two IDEs out of it. So the first IDE, they call it as a SAP HANA Studio. Okay, so if you want to interact with HANA database, if you want to see different tables in HANA database, we generally make use of this HANA Studio. That's one of the tool which we need to understand if you want to start working on ABAP on HANA related projects. Right. The second tool, what they have also brought in and what they have built on top of this platform is the ABAP development tools, which is ADT. So this is the tool which actually gives us the feasibility to start working on top of HANA layer and build few programs using ABAP programming language. That's the main goal of this ADT tool. So let's say if you want to create a report, a program in the latest versions of NetWeaver, say 7.5, 7.6, right? So in that case, you generally or mostly start using this ADT because what SAP has done with the introduction of SAP HANA is they have removed few interactions what we generally go and do inside this SAP GUI, right? So they are also increasing developers to get accustomed to this using this particular ADT tool and start doing developments using this particular tool. And let's say if you want to create a serious view, right? So all these things we'll be generally doing inside this ADT only. So we'll be covering these two tools in our upcoming sessions, how to use it, how to configure everything, right? And whatever the tool we are using, and this is being used by a developer, which are, say, whoever an ABAP developer who starts working on this ABAP HANA related projects, right? They generally use these tools. Most of the time they use ADTs, but there will be cases where we also need to have access to HANA Studio just to understand few underlying concepts of the database tables, right? But initially, if you take a classical database, how we generally used to access the tables inside the classical database in a ERP system, we generally log on to that particular system via SAP GUI, and we used to access it, right? No, but when you try to start using SAP HANA database and if you try to interact with HANA database, so these are the two different steps which we follow. And why SAP has brought in this particular new tool called ADT. So obviously, if someone is bringing or creating or developing a new tool, it definitely needs to address few benefits, and also it also needs to remove few bottlenecks, right? So until unless the new tool is doing these two things, it will not get the response what it's expected, right? So we'll see what are the different benefits of Eclipse will have. So with the ABAP development tools in Eclipse, we actually get the benefit from the usability perspective. That means the tool is pretty simple and straightforward to use, and it gives us the speed. So when I say speed, if you want to go between two different systems, right? Let's say I'm creating I'm developing a report and a program, and now I want to access the HANA database tables. Again, I need to go to the other tool or HANA Studio. I need to open it and I want to see the data, right? So what ADT does is it gives us the feasibility of directly interacting our program with HANA database itself, right? So let's say, I'll not call that as a different how we try to code a program in the current ERP landscape with the traditional database. But there are few benefits what I can show you when we start doing this programming with. I can show you all those benefits, what we'll get. Right? And this particular development tool improves the developer productivity by better reflecting functionality. It also gives us few code completion aspects, right? It provides us few templates, and it also gives us few auto insertion features as well. So these are all the different add-ons what we'll get in terms of using this ADT, right? So once you have the glimpse of this ADT, you can understand like we'll have different perspectives in it, or we call it as a views, right? So based on your requirement, you can jump to that particular view and you can start directly working on top of your systems itself. And this tool allows us also to connect to multiple ABAP systems, right? And it provides a session failover. That means if the sessions are lost, right? So if we need more sessions, it actually reduces that impact of these lost connections, right? It gives us the feasibility to get connected to multiple ABAP systems in a single ID. It also enables the cross-platform development by integrating this ABAP and non-ABAP development tools. So let's say you have an ADT with you, right? And you started working on an ABAP or a SAP project, right? So now inside your project, you got a reference where you need to create a Java project or an EJB, and out of that EJB, you want to create some web service, right? So that's a non-ABAP development part. So the same thing can also be done within this ADT itself. There is no need for you to go to other platform and try to create it. Let's say if you are using this traditional SAP GUI, right? So what you used to do, so all your ABAP related development you'll be doing inside this GUI. And when you need to create a AGB or a web service, right, you need to go to Eclipse and start doing it. But what this ADT provides us is the ability to do the development of the ABAP as well as non-ABAP development projects as well. That's also a beautiful feature what this particular ADT is providing to us. And these are the different things what will we do. So this is screenshot is just for a reference, just try to understand different things. Anyways, we'll be doing everything hands-on once we get hold of the system. Okay. So the first and foremost thing is, so we'll connect to a backend system, right? So let's say I have an Eclipse. This is a brand new tool which I downloaded from SAP. And the first and foremost thing what I need to do is I need to set up a connection, right, with my Eclipse to my backend SAP system. Let's say in our case, it's an ABAP system, right? So once the connection is set up, right, once the connection is set up, we'll be able to access any ABAP repository. So when I say ABAP repository, like let's say if you want to access a package in traditional ERP system, right, we generally go to CAT, select the package, do the project name, and you should be able to do it, right? So similarly, the same set of activities, we can also do it inside this particular ADT as well, right? So you can create classes, right? And you can create function tools, you can create interfaces, you can create ABAP programs. Along with all these things, you can also able to access the SAP delivered classes, functional modules, wrappers, everything inside this ADT as well. So once you get hold of this ADT, once you understand how this particular ADT works, there is no need for you to go again log in traditional SAP GUI and start using that. Okay, everything you can access from here itself, right? And here also gives us the feasibility of making a package as your favorite. That's like if you're using that package very frequently, right? You can make that as a favorite so that you can just open your ADT, just double click, and you can directly log into your package. So these are the different things we can do once we have this ADT, right? So how we can edit this code. Let's say here we can saw that, let's say we have a sample program, right? So here HA 400 underscore case underscore study underscore S1. So this is a program what we have inside our package, let's say, right? If I just double click on that, you'll be able to see this particular screen, right? And if you want assistance, like if you want to understand what may be the interface name, what is the method name, right? All those things, if you do a control space, it will give you a hint, like this may be the one which you can use, right? Based on that, you can just select it. So let's say you have a class and you have 4 to 5 methods. You don't know the method names. If you just put a control space, it will show all the methods. So what you can do is you can select based on the method name, and obviously you'll be having an idea of what are the methods does, right? So based on the functionality, you can just select that method and start implementing it. That's the content assist feature it provides, and we can get the content assist feature by using the control space inside the editor. And we also have a quick fix feature. Actually, if you do a control +1, it gives us the quick fix feature. So what this quick fix feature does is, so in the screenshot, below screenshot, you can see when I selected this interfaces as GIF underscore calculator, it is showing me a warning, right? So when I click control +1 on that particular warning, below you can see it gives me a few methods. So the first thing how I can fix it is we can add we can add all those implemented interfaces, right? Because this is an interface. So we did not implement it. That's the reason it is giving the warning. So what we can do as a fix is we can add unimplemented methods. So if you just click on that first method, it will automatically implement those methods inside your class. That's what a quick fix does. It gives recommendations, and also if you just accept those recommendations, it will go and implement it. That's the feature what we have. So in the coming sessions, we'll be working on a few objects where we will do this performance improvements and optimization. There, I'll show you how this quick fix helps us. Okay. So this is a good feature what they have brought in, because this one we do not have it inside this traditional GUI screen, right? Quick fix is a good feature. I can show you when we start working on the real-time scenarios. And we can also do the debugging, right? So debugging is a very important part for the developer, because once if something goes wrong in the program what we have written, and if it is not displaying the result what we are expecting, right? We need to be in a position to debug that code and resolve it, right? Or to know the root cause, we definitely need to do a debug of our code. So we can also do this debugging of our ABAP code inside this IDE only, ADT. So there is no need for you to again go back to your traditional GUI, or you will not get any traditional GUI screen which you used to see when you are working on as a normal ABAP developer, right? So once you start working inside this particular ABAP development tools, everything you'll see it here. So if you see to the right side, you can see the variables list. And if you see at the bottom, right, you can see all the code. And from there on, you can slowly go ahead. And the buttons which are highlighted at the top are the ones which we generally use. F5, F6, F8, right? These are all the different steps what we use. So I just want to reiterate. So I just want to give you a glimpse of how the tool looks like, what are the different things we do, but everything whatever I'm showing you in terms of this presentation, everything will be doing the same on the system as well. And how we can get this particular EDP, right? So let's say you started working on it and you want to download this EDP, right? So you can do the download in the download center, right? And once you download, you need to do a few steps in order to configure the relevant libraries or the tools. I'll again show you how to configure it once we get hold of the system. And it's pretty straightforward. We just use these URLs. After you download the EDT, we use few URLs to configure it. And once they are installed on the Eclipse, you should be ready to go with your development. That's all for this particular topic. Now, let's move to other topic. Okay, that's just give me some space. So now we'll jump to the next module, right? So this is also an important topic what we'll be discussing, right? Oops, I think I missed it. Just give me a second. So this is the second module what we'll be talking about. So we saw the basics of HANA server. We saw what are the different tools we need and what are the different benefits we get, right? So now we'll talk about the database part, right? Yesterday, if you remember, I tried to bring in this particular point in one of our discussion, like HANA, how in the evolution of HANA, how they have brought it, right? So they initially brought it as a secondary database, and slowly they pushed it to HANA as a primary database. That's how the HANA has evolved, right? So we'll talk about that particular point. So what is this necessity to install HANA as a secondary database, right? So what is the necessity to install HANA as a secondary database, right? So if you're following this particular architecture, right? So what happens is we are already having our primary database, which is Oracle or MS SQL or MaxDB. Along with that, we have added a new database, which is HANA, and we have configured it to work as a secondary database. Right? So why we generally do that, or what is the necessity, right? So let's say we have few programs or reports, right, which is taking a humongous amount of execution time when we're trying it on a primary database, right? We have done a lot of analysis around it, and we came to a conclusion that our system is very stable, and whatever the objects we have built are pretty much optimized and they are working fine. But we don't want to run all our other reports, transactions on it, because we are not seeing any improvements. So what we can do is we can try to run those programs or reports, right, to run on SAP HANA database, which we have just gotten as a secondary database, as they are taking too much of time, even after performing all sorts of the performance improvement techniques on top of it. Right? So this generally happens because of the limitation of the non-SAP HANA database, right? As we all know, SAP HANA deployment empowers a business with speed. The main selling point of SAP HANA database is its speed, because SAP claims that the speed is approximately 3,600 times faster than the traditional database while it is doing the calculations or when it is doing the transactions. That's the key selling point of SAP in terms of SAP HANA database. So if we want to accelerate all these programs or transactions, which is taking more time for execution in the traditional database, one of the options we can think or to make it work efficiently is to go and try it to run it on our secondary database, which is HANA. Right? That's what the necessity is. So let's see how does this particular work, right? Now simply we'll take a simple report. Let's say we have a report A, right? Or let's say we have a report which actually displays all the sales orders for a particular set of customers in a region, right? So that report is very slow, and we are thinking of ways how we can make it to execute quickly, right? As we discussed earlier, we have done all sorts of analysis, and we came to the conclusion that we have done 100% in terms of optimization of the report. We can't do anything. We have improved the hardware of the servers, but nothing is going around, right? So we need to think of an alternative way. So what we have to think is, we need to identify all the database tables used in that report, right? Once we identify all those database tables, now we got to know, or we got to know that there are around, say, 5 to 8 database tables. Let's say 8. Here we have 8 data tables which are being used inside that particular report, right? So all those 8 data tables which we have identified in the report are available in the primary database, right? And also the relevant data inside the tables are also stored in the primary database. right? So the data of these 8 database tables, what we have been using inside this particular report. Now what we'll try to do is, we'll try to replicate the exact data from our primary database to the SAP HANA database using the SLD. Right? Somehow we push the data from our primary database to a secondary database. SLD is nothing but a real-time data replication tool which we use. Right? Let's say we have pushed the data from the primary database to the secondary database. So once the data is residing inside the HANA database table, right, the reports which are running on the primary database can read data directly from the HANA database instead of the primary database. Right? This is how it works. So let's say you have done all this part, and now if you want to try to run this report, so what we'll do is, instead of going to the primary database, we ask the report to connect to secondary database, which is our HANA system, and try to execute it. Right? How can we achieve this? Okay, we are saying that we need to tell the report to go there, but how can we achieve this? Right? So this can be done with the help of setting up a secondary database connection. So this is more of a basis related stuff. We'll not be doing it, but I just want you guys to understand the concept of how this secondary database connections work. So this can be done with the help of a concept called the secondary database connection. Right? So the connection from the primary database to a secondary database is established using a T code called DBA cockpit. That's the T code which we use if you want to set up a connection from the primary database to the secondary database. Right? So there will be a slight change in the select queries of the reports, right? In order to reading the data, right? And we also need to do a few changes in adding a connection as well, right? But the rest of the things remain same. So each application server ABAP is connected to the DBMS that contains ABAP repository, right? So whatever the primary database what we have, you take anything, MS SQL, Oracle, or anything, it does not matter to us. So once we brought in SAP HANA as a secondary database and you have set up a connection using the transaction code DBA cockpit, right? Your system should be good to run that report on top of your secondary database, which is HANA. So each database connection is identified by a name, which must be unique within the application server, right? It should not give the same name to different set of connections. So this is how the screen of a DBA cockpit T code looks like. So if you go to this particular DBA cockpit T code, and if you click on this database connections, here you should see the connections. So here we have already created a connection called HANA DB. We have provided the DB host and the username. And if you click on test, it should be working fine. This is how a sidecar scenario system should look like. So if you go to a system where your HANA DB is a primary database, you will not see anything here because it's a single database. You can see some kind of entries in this particular P code and inside this database connection. So only if you're running on a sidecar scenario. And this can be used to access local or remote database systems, right? And all these settings, what we are trying to set up will be done inside the P code called DBA cockpit. Okay. It is simply a normal connection type what we do, right? By giving the host name and the port and everything. Once this particular connection is set up and you have tested it successfully, and now what you can do is go back to your report. If you see here in the screenshot, I opened the same report, and here I am explicitly specifying the connection what I have created in my previous screenshot. Here you can see the connection name is HANA DB, right? So here inside the program, I'm specifically or explicitly specifying that when trying to do a select query on these tables, instead of going to the primary, by default, please go to the secondary connection which I have just created. And how can we tell to the program that go to the secondary connection? By using a keyword called connection and provide the connection name over there, which you have created in the DBA cockpit P code. Okay. Once you provide this particular connection, so once you run this program, right, what happens is, based on the connection parameters, the query, the select query, will now go and hit the HANA database instead of the primary database. That is what our intention is, right? So only tables and fields that are defined in the local ABAP dictionary can be accessed using this data packets connection. Okay. So in HANA, we have a few things called views and procedures. So we cannot access those objects using this secondary database connection, right? So only the tables inside the schema, which are assigned to the DB user, which we have used in the connection, can be used. So if you see here, we have used a username called repzme, right? So only the relevant objects which are assigned to this particular username can be accessed inside this particular programs. Only those tables can be assigned. So I also want to bring you one more point here, right? So in this particular, or once you set up a secondary database connection, right? So you can access that particular data via OpenSQL and also as native SQL, right? So the easiest solution for performing this SQL operation from ABAP to this secondary database connection is obviously by using the OpenSQL statements, like what we have saw here, by just using this connection keyword. And once it is connected, you should be able to access the relevant data. So the advantages of this OpenSQL is simplicity. It is pretty much straightforward. Just use a keyword, and we know how to write queries using ABAP languages, right? So that's the reason why we mostly go for the OpenSQL, right? So, but we can also do the same thing via native SQL as well, right? So we can write the database-specific SQL statements, which allows us to connect to the secondary database using native SQL. But as you know, the native SQL is not straightforward. We need to write a lot of steps, like we need to write, say we need to open a connection first, like similarly what we do here. And we also write separate statements like execSQL, which is the keyword to execute the statement. But here there is no need for you to write all this stuff. So the major disadvantage of using native SQL, right, via execSQL is that the statement contains significantly more code when you compare to the OpenSQL. That's one of the drawbacks what we have. So if you want to work using native SQL, we need to write a lot of code, right? So it's also less elegant to understand because it uses the database cursors concept. So that's not really fair, and it does not give you the essence of SAP HANA server. So that's why we generally go for using the OpenSQL only. So the next topic what we'll talk about is what are the different code checks we need to do from a ABAP developer perspective when we are working on SAP HANA projects. So now the current trend, what is happening is most of the customers are migrating from their traditional ERP systems to SAP HANA systems. Either they're going to the sidecar or they're completely migrating from ERP to S4 HANA or SAP HANA. Both are one and the same in terms of migration, right? If they are just doing it from the DB perspective, right, whatever the task we'll be doing should be considering in terms of an ABAP code, right? What are the different considerations we need to take as an ABAP developer when we are working on this kind of migration projects, right? What are all the potential functional issues we may face and how we can try to solve them? So these are the different things we'll be talking about here. So what are the main considerations what we'll get, right, when you start working on this one, right? So let's say you are deployed into a new SAP migration project where your party is like a technical developer, right, or a technical analyst. So what is the first point it comes in mind? Because there is no need for us to worry about the standard programs, standard function modules and all, because SAP takes care of it when when we're doing this kind of a migration and moving it to HANA. The real problem comes to our mind is what happens to the existing custom code and the existing functionalities, right? Which of my ABAP code must be changed to avoid potential functional issues when migrating to SAP HANA, right? So if you just look at your report or a program, so we'll not be able to come to a conclusion whether this program will work when you migrate to HANA or not, right? We need to understand what must be changed or what must be corrected so that my program, custom program, goes and works in the migrated SAP HANA. Which of my ABAP code shall be optimized to ensure good performance? I wrote a report on traditional ERP system. Everything is going good, that's fine. But if I move it to the new system, still can I optimize it further so that I can get a good performance out of it? Other consideration is which of my main business processes have potential for SAP HANA so that I can speed those up massively. We also need to identify different business processes where we can actually speed the execution time of those reports, what the business users are executing in their real time day-to-day jobs, right? When we are migrating to SAP HANA. And the final and important consideration is, okay, I got the points, like I need to all this stuff, but how can I find all this ABAP code easy and do the adoption efficiently, right? Yes, I understood that these are the things I need to consider, but how I can find which program is having issues? What are the different automation techniques I can use or tools I can use to achieve this particular considerations in reality, right? Let's see few potential issues. Potential foremost thing what we need to consider is the native SQL statements. So we need to check if the native SQL uses vendor-specific statements, right? Vendor-specific statements means, so when you say native SQL, it's like if you use Oracle, the statements will be different when trying to connect and access the database. When you use MS SQL, the pattern of statements or the keywords what you use is different, right? So that's one of the disadvantage of using a native SQL. Those are vendor-specific. And if you are using those native specific statements inside your reports, first we need to identify in which reports we are using them and how we can replace them by the open SQL statements or by the native SAP HANA constructs. Right? These are two other different things what we can do. We also need to check if previously used hints are still needed or not, because we will have the concepts of hints, right? So we also need to check if those particular hints are needed or not. If not needed, you can just remove it. Okay, those are also different things we need to check as well. Right, so these are like our database hints. So we'll not be talking much about this one because these are just like to provide some hints to specify at the database level. Right, we generally use this kind of percentage for hints after the select statements or the where conditions. Right, these are the few potential function issues what we can check or what we need to check. Right, and if you recall yesterday's session, we also discussed that there is no concept of pool or cluster tables, right? There is no concept of pool or cluster tables in SAP HANA DB, right? So we need to check if there is any direct access to physical pool or cluster tables as well. And we also need to check the existence of secondary indices because with the introduction of SAP HANA DB, they have completely removed the concept of the secondary indexes. Right? And we also need to check if you are relying on the implicit sorting, which we generally do it on top of the pool or cluster tables. Right? So these are the few potential functional issues what we can consider when trying to work on a migration project. So we use two tools, right? So these two are the important tools which we use when we start working on this particular migration project. Okay. So these two are the two important tools what we generally use when you start working on a migration project, right? So what are these tools, right? Let's talk about these tools first, right? What are these tools and how I can use it, right? So as we know, we'll be having lots and lots of custom code which is written by so many developers, right, to achieve various business requirements, right? How can we guarantee that everything will work once the migration is completed, right? To check or to get a clarity or to get the confidence on that particular part, SAP has provided us with two tools, right? And this is not a tool, this is not a new tool which is provided by SAP on top of HANA. These tools are existing from many years, but we started using mostly when we are doing this kind of a migration project. Okay, so these tools or these two tools helps us or supports us to plan and decide that our move to HANA database is smooth by ensuring that none of the cases, like the failed cases, like database issues, native executions, all those things will not happen to our custom codes, and the functionalities will not break once the migration is complete. Right? So what are these tools? The first tool we called it as a SAP Code Inspector or SCI. We call the first tool as SAP Code Inspector or SCI. And the second tool what we have is the ABAP Test Cockpit. This ATC, ABAP Test Cockpit. So why there are two tools, right? Because SAP has provided two tools. So is it not, or one tool is not sufficient? Definitely we need to use both the tools, right? That will be the question which comes into your mind. So both these tools does the same job, right? Does the same job, but the USP is different. USP of the each tool is different. So what we'll try to do is we'll try to do a scenario using both this Code Inspector and ABAP Test Cockpit. Then you'll understand how these two tools will behave. Okay. And then we'll talk about what are the disadvantages we have when using ATC or SCA. Okay. So this is the screenshot what I have put in, right? So we'll have few important variants which we need to use, right, when you're trying to do this or use this Code Inspector or ABAP Test Cockpit. So you can see the screenshot here. The functional variant, the check variant what I have used is function_db, right? And once I execute this particular variant, and I can see different set of values which I got, right? And I can see all this stuff. So what this particular Code Inspector checks, right? So it mainly checks for the critical statement. So it searches for the DB hints and the native SQL statements. So if it finds any the DB hints and the native SQL statements, it gives us back with a error message that, hey, this is a critical statement, what you need to fix, until unless you cannot move forward, right? Those we call it as a critical statements, right? The use of ADBC interface. So I'll not talk about ADBCs much. I'll just skip this particular point. We'll talk about ADBC when the time comes. It also searches for the DB operations in the pool of cluster tables. Because on top of SAP HANA, we know that this pool of cluster tables does not exist, right? So it searches for the direct access to those pool tables and table clusters, and it gives us the result back. We need to do the necessary corrections to it or the necessary adjustments to those kind of tables. It also searches the problematic statements for the result of select or open cursor without order by, right? Along with the critical statement, it also checks for the optimization part as well. So if there are no state, if let's say you wrote a select statement and if you did not write any order by, right? It gives us that as a result back. Right? It says that you need to follow few database performance rules in order to improve your report performance on top of HANA. So these are the different uh, suggestions it provides us back. And once we correct all those things, we should, or we can confidently say that, yes, my custom report, which I have built, will definitely go and work on top of SAP HANA once it is migrated. That's the confidence this tool gives us. So yeah, this is also arbitrary patterns what we have. So if we have this kind of function doing this, right? So all these things we can just find it out. So once you execute it, right? So once you execute that SCI, right? This is the result, or this is how the result looks like. So here it is clearly saying that, right? It is providing you with a few statements. It has got a statement where you did not use a order by after the select. So it will tell you that go back to this particular line, do the necessary adjustments, and you should be good to go. These are the different kind of suggestions this particular tool provides. Right. So now we'll talk about the tools which we use to analyze the performance issues. So how these particular tools helps us in identifying these performance issues, right? So it gives us, or what is the reason for the performance issue, and what are the tools we use to measure and compare the runtime consumptions, and how we can search for potential performance issues using the two tools which we discussed earlier, which is Code Inspector and ABAP Task Cockpit. And we also use a SQL trace code ST05 to do the in-depth analysis of the database accesses. These are the topics what we'll be covering in this particular presentation. Right? So, or the tool what we need is how the performance of the existing ABAP code will perform after the migration is completed, right? So some code may immediately, or some, when I say code, it may be a report or a program or a functional module, right? Some code immediately runs faster, right? Some code might be negatively impacted and we should be revisited that particular code, right? We are not so sure how it happens. We have done the necessary migrations and improvements, but we are not so sure how this particular thing will work, right? So we can do this runtime analysis by doing a ABAP trace. So we can put a trace for the program and we can try to measure, right, based on that measure. So how many or how much of time your OpenSQL statements are taking, and if you have any statements in terms of native SQL, right, we can also get a trace of that as well using the ABAP trace. We call that as a runtime analysis, what we do inside the workbench. So what are the different characteristics we have, or what do using the ABAP runtime analysis and the trace? The functions of the classic ABAP runtime analysis, which we do in the SE30 code, right? If we want to do a ABAP runtime analysis, we go to the T code SE30. And we have a new tool called SAT, right, which takes the ABAP trace, which can be completely used in the SAP HANA context. So SAT is a good tool, what we can use if you want to get the ABAP trace. So both the tools function one and the same. They measure the runtime of the processing blocks. So once you run a report or a program, it clearly tells you which method took how much amount of time, which function took how much of a time, or it also provides the execution for a single statement as well. So based on that, we can identify the bottleneck of which statement is taking much execution time and is totally or impacting the overall performance of the report or a program. So this is what a runtime analysis we can see in the edit itself. There is no need for you to go again outside. So you can see this runtime analysis in the ABAP development tools itself. Right. So once we do the performance checks inside the Code Inspector and ABAP Task Cockpit, that means we have set the problematic select start statements. We have also identified the loops across different modules or subroutines, and we also had search for the for all entries clauses to be transformed. So these things we need to do just to improve the performance aspects in terms of the identified custom code. So these are all the different things what we'll be doing. So I'll show you by sampled programs, right? So I'll try to showcase you the difference, how it will push us back when we use those select star statements, and if we use few keywords which we should not use, and how we can correct them once the system tells us this is what you need to correct. So we can just see everything using sample programs on the live system. So this is the in-depth analysis of the performance issues, right? So if you go to the ST05 T code, you can clearly see which object, which statement has taken how much amount of processing time. So generally, this particular T code displays the record of all database accesses, right? If you have a sidecar scenario in your landscape, so it also includes those SQL calls as well in this particular transaction code ST05, right? So once we have a look at this particular report, we can easily identify which select statement is eating more amount of time. Based on that, we can revisit that particular statement and do the necessary optimizing steps on top of it, right? So it displays all this database execution plan for all the statements. This is a good decode what we can use when you are doing some analysis on top of a report or a program in terms of the performance issues. What are the different uses of this SQL trace ST05? So ST05 is a T code which you need to execute in the GUI or the ADT if you want to do a SQL trace. So it actually displays us the record of all the database accesses. It provides us the list of activities or the select statements or the database activities which are involved in that particular report or a program. It easily detects those identical select statements, and it provides a simple list like this particular select star statement has took this amount of time, right? Based on that, we can take our call and we can start fixing those statements so that they are optimized. Yeah, this is how we generally do a performance trace. So go to ST05, right? Execute the trace. You want SQL trace, right? Just select that SQL trace, and you can activate trace with filter, because what happens is if you are now trying to run a report, if you put this activate trace, if let's say if you are trying to put this trace on a production system just to identify the real-time performance of the report, right? So how many users are, let's say 100 plus users are logged into your production system. So the trace of all those 100 plus users will be taken into consideration. Just to eradicate that, if you use the option called activate trace with filter, it will ask you for the username for which you want the trace. So in that case, just provide the username of the user who is actually running to run that particular report or program for which you are trying to get a trace of it. First, click on this and run the report. All the entries will be captured. Come back to this T code, click on the deactivate trace, and then click on the display trace. Then you should be able to see all the select statements, whatever or what are being used inside that particular custom report or a program. But this is how we generally take the performance trace using the ST05 T code. This is something called an execution plan. We will not use much. This is more kind of an database related activity. So I will not touch base this one. So let's say you have identified a report, and that report is being executed by one user. So the first and foremost thing what you need to do is come to this particular ST05 T code, and you will see this particular screen. The first and foremost thing what you need to select is the trace type. What type of trace you want to do, right? Select this SQL trace, because we are focusing more on the database related performance. So we have selected SQL trace. Select this SQL trace, click on activate trace with filter. Once you click on this activate trace with filter, it will ask you to provide a username. So username is the one who actually runs the report for which we are trying to take a trace, right? Let's say Joseph. Joseph is a person who is actually trying to run the report for which we want to trace. So we will, before Joseph runs the report, we will enter the Joseph's username by clicking this button, activate trace with filter, and provide the Joseph name inside this username details and say execute, right? That's the first step. Once that is done, we'll go back to the Joseph and ask him to run the report. Once Joseph executes, completing the report, once he confirms that the report is completely executed, we come back to this particular ST05, click on the deactivate trace button. Once you click on the deactivate trace button, the display trace will be enabled. Then click on the display trace to see the trace entries. So we'll jump to the next topic. Now, guided performance analysis. So we'll be touch basing two other tools. You can call this two other tools which we use when working on this kind of performance improvements or performance analysis. Right? These two are also important tools. The first one is SQLM. That's a T code what we use. So this is to understand the SQL monitoring part. And the second T code or tool what we use is SWLT. This is a performance tuning worklist T code. So these are the two other tools which we can use when you are trying to do the optimization in terms of performance. What are the different steps we use, right? So the first and foremost step we use in terms of performance optimization is we do a static code check. So what is a static code check? It is to identify the location of the known critical code issues. That we will select by star, you don't use any order by all those stuff. So what is the tool which we use to do this particular static code checks? We can either use SAP Code Inspector SCI or we can use ABAP Test Cockpit. We can use any of the tool to do the static code checks. And in which system we need to do this code check? We need to do this particular code check or we need to execute this tool in the development system. That's the important point which we need to remember. The second step is, once we are done with the static code checks, the second step is we need to get the runtime information out of the production system, right? So we need to understand what are the programs which are being mostly used by the customers on the live production system, and also what are the different programs and reports which are being mostly used, right? Until and unless we identify those aspects, right? So let's say we have around 1,000+ objects in the live system, and you just can't go and dump all those 1,000+ objects and start doing performance optimization, right? So we need to make a plan. So how we'll prepare a plan? We go to the live system, right? We try to get the runtime information out of this production system, like mostly used reports, mostly active programs. We get the top list, let's say top 100 or so, the most important and the critical ones for the business to run, right? We get those lists. So how can we get that particular list? Using the tool called SQL Monitor, right? So that's why we should run this SQL Monitor in the production system, right? This tool mainly helps us to monitor the most expensive SQL statements in your production system. Okay? This tool helps us to monitor the most expensive SQL statements in the production system. Once we understand, right? Once we understand this particular data, or once we have the data, like how much execution time this particular programs is taking and all, what we do is we generally we have a what you call a technical word called snapshot. We take a snapshot of that particular output, and then we'll export it, and then we'll import that particular snapshot into the development to start our analysis. And where we are, or once we get the SQL monitor snapshot, we need to go to the next list just to prioritize, right? We use a tool called SWLT, SQL Performance Tuning Worklist. Okay, this is what SWLT is. So, what are the prerequisites we should need in order for you to run this SWLT? Is we must have run the SQL monitor in the production system, and we have created a snapshot out of the data, right? As I said earlier, we'll export that particular snapshot and import it in the development system. And inside the development system, the second step is we configure and run the ABAP Task Cockpit APC or the Code Inspector on top of it. What this particular SWLT does is it combines, right? It combines the results of static code checks, which we got from the ATC, and also the results which we got from the SQL monitor. Got my point? So it combines both these results, and then it gives us the report like these are all the these are all the mostly affected or used programs, right? Which are being affected in terms of performance. And we can just start focusing on those particular programs and the statements and then do the necessary corrections. This is the step-by-step guide what we can follow when you want to do a performance optimization. The first step, the static code checks, will be doing it on the system. The SQL monitor will do it on the production system, right? And we'll combine these two, one into static code checks and the runtime information which we got from production system inside the SWLT tool to prioritize the work list. And then based on that to do the optimization. This is how the SQLM looks like, right? So once you execute all this, right? So if you see here, the execution time is more. So this is like this particular program is eating a lot of DB space, and also it is taking too much of time, execution time, right? So these are the different findings what we can get when we run this SQLM monitor, the production system. So they have brought in few things, which they call it as a new ABAP SQL monitor. It's almost one and the same. So instead of this monitor transactions, right? So they read the data from the database tables. So they just keep on monitoring the data, which is being moved here and there via the batch jobs, which are specific to those database tables. So these are the important three things what we should do when you are trying to focus on the performance optimization. To go and use the SCI or ABAP test cockpit, to use the SQL monitor, and then to use the SWLT. So how can we switch on this SQL monitor? Because we are doing, just to remember, right? So we are doing this SQL monitor on top of a production system. So once you are set to take the snapshot, then only you need to go to this cheat code SQLM, right? And switch on this monitor. And once everything is done, then you can simply switch off it. That's what we do. And I will also show you how to take the snapshot, how to export it, how to import it, development, everything on the system in the coming sessions. And you can also see the SQL monitor data, whatever you got. Either you can go to a separate code called SQLMD, or directly we can navigate inside this SQLM only and to see the data. So I can show you those two things as well. So as I said earlier, once you got the snapshot, right? Once we get the snapshot, which is saved on the production system, we'll export the snapshot which we got in the production system and import that particular snapshot into the development system to start our analysis. We can, what they have done here is SWLT. Sorry, I think the code is wrong. SWLT. So here it does the SQL monitoring. It analyzes the SQL profiles, right, to identify which business processes should be optimized. Along with that, with the help of ABAP test cockpit results, we also identify what ABAP code should be optimized, right? So the SWLT allows us to correlate the SQL runtime data with the ABAP code analysis and to plan for the final optimization. We combine these two inside this SWLT to prepare a plan for the optimization. Once you execute this SWLT, right, this is how it looks like. So you will get a list, right? It gives us a list like these are the top. So if you see here, there are different request entry points. If you click on any of the record, right? Once you filtered it based on execution time, if you select any of the record, at the bottom, you can see the SQL monitor result, right? What are the different entry points? What are the different methods? What is the class which has used? Everything you can see. To the right side, you can also see the ATC check results. So ATC check results are more specific to a statement, like select star, order by, usage of native SQL statements. All those things will be, from a code perspective, will be shown in the ATC checks, right? This is an important topic because when you are working on a migration project, this one you should definitely need to consider. Or people will ask you to provide the plan for this kind of activities in the migration projects. So you are not comparing at a code level. So the first one does a code check. The second one, the SQL monitor actually gives you the mostly used reports on the program names. If you see here, it gives you the fully used or the reports which are taking too much of time from a database level. Not do the code checks. It just gives you the full report of the database interactions. The SCI will give us the issues or locations where we have problems in terms of code statements. We try to combine these two to finally get a single screen where you can do these corrections. Just make a note of it. Anyways, we'll be doing a couple of examples on SCI, and then we'll try to take the snapshot. We'll do each and everything. So we should be good. Try to understand the concepts, and when we start working on the system, then you try to correlate. I think then you'll get a better picture if you have a little bit of confusion over here. This is the T code. The tool, whatever we are calling it as a tool, right? It's like ATC. It's a T code ATC. Other T code called SCI. SAP code inspector. Those are the T codes here. We just call it as tool, but those are T codes. Anyways, we'll run it on the system, so I'll show you more clearly when I'm doing it on the system.
Hey there, ready to dive into the world of SAP ABAP programming and SAP ABAP on HANA? Our course is your ticket to mastering these crucial skills. Take it at your own pace right here on our platform. In this course, we'll unravel the mysteries of SAP ABAP. It's like having a super handy toolbox for planning and managing supplies, ensuring everything flows smoothly from production to delivery. We've got you covered from the basics to advanced techniques. Crafted by seasoned experts, this course is packed with knowledge you won't find anywhere else. Your instructors, top-notch pros with years of experience. They're here to guide you every step of the way and clear up any doubts you may have. But don't just take our word for it. Our students rave about how helpful this course is. People just like you have found immense value in what we offer. And the best part, it's incredibly affordable. This amazing opportunity to level up your skills won't break the bank. Ready to become an SAP ABAP wizard? Enroll now on our page. For more details, head over to ZaranTech's website.
So we call this as the golden rules for SQL, right? So if you are trying to optimize or improve the performance of your custom built application on top of S4HANA, right? So these are the golden rules, what we need to follow. And whatever the rules we are checking out, it will be linked to the OpenSQL, right? So because OpenSQL is the one which we'll be using most, right? So we'll be talking about the rules which are valid for OpenSQL statements. So we'll be talking about these golden rules in terms of the performance guidelines. So to improve the performance of the SQL and in turn of the entire ABAP program or report, right, we should take care of the following rules. The first one is we need to keep the result set small, right? So nowadays we got a lot of traction around performance and optimization. So we are writing better code while we are actually starting the development from the scratch. But in the good old days, like if you go back 10 years or so, at that time, building a functionality important rather than concentrating on the optimization of the performance. Yeah, obviously they used to put some effort in terms of performance, but not that much, right? So how can we keep the result set small in terms of the SQL statements, right? So we're not at all talking in terms of the application performance or increasing the hardware or something like that. We are talking in terms of the SQL statements, what we'll be writing as an ABAP developer. The first guideline is you need to keep your result set small. How can we keep our result set small? Right? We can use small techniques like you can use where clause, right? So based on your where condition, just add a where clause to your select statement, and based on your requirement, get only that amount of data. And the second thing what we can do is, if your trying to get only one record. Let's say you're writing a select query where based on your where query, you'll get only one record, right? So let's say you have a material number, you are trying to get the relevant details of that particular material number, right? Obviously, you'll get only one particular entry for that. Like if you want to get a description of that particular material, right? So in those conditions, if you're trying to get only one record from the database, what we can suggest or what we can follow is we need to use select single whenever it is possible, right? So generally we write select column names and from table, right? So instead of doing that, if you know that you'll get always only one record from the table, or if you need only one record from the database table, right? We suggest you to use select single, right? That actually gives us, or those where using the where clause, using the select single statement keeps us our result sets pretty small. And the second thing is minimize the amount of transferred data. What is the second thing? Minimize the amount of data transferred or the transferred data. We need to restrict the number of lines. So whatever the data we are trying to pull in, right? So based on a requirement, we need to get the data. So if we require only certain fields from a particular database table, right? So just don't write select star from table and you put all those fields into internal table and then start to pick your selected fields, right? We generally don't do that. If you want a good performance in terms of the application or report, whatever you're building, right? So we need to be certain that only the fields which are required for our usage in the report or program, those certain fields only will be pulled from the table, right? Like using the select statement followed by the relevant field names, whatever we want into an internal table and directly use that set for your next set of calculations. We need to minimize the amount of data transferred. And we also need to restrict the number of columns, right? So if you, based on your need, if you need only 3 to 4 columns in a particular table, just focus or get only those columns, whatever you require, or whatever the data you require from those columns. And we need to use the aggregate functions. So aggregate functions are like using some average, max, min. So all those functions, we call them as aggregate functions. So whenever you have the possibility of using those aggregate functions, we suggest you use those aggregate functions so that the load on the data will be reduced. And the third golden rule is minimize the number of database accesses, right? So minimize the number of database transfers, also we can call. The first and foremost thing what we need to eradicate when trying to build a program, right? Or when you're trying to do a performance improvement on a report or program, right? We should never write these nested select loops. So those cause or those affects the performance of your report a lot. So avoid nested select loops, right? So never write this nested select loops. So if you have a requirement of to get 2 select statements executed at the same time, right? So the alternate option, what we can use is to select for all onto statement. Instead of writing a loops, 2 nested loops, what we can do as an alternate option is we can write a select all for all enter statement. So this statement can be a lot more efficient, right? So this statement, the select for all entries, can be more efficient than performing a large number of select statements inside a loop of an internal table, right? So rather than using these nested select loops, we would suggest you to use select for enter statement, and based on that, you do your next execution steps. Right? And also wherever and whenever is possible, go for the usage of dictionary views, right? So I hope you guys know what a view is, right? So use dictionary views. And we have also joins in our traditional ERPs. There is no need for you to be an S4HANA to use the joins, right? So we can also make use of joins in the from clause. And wherever possible, I suggest you to use these subqueries in the where clause, right? So whenever possible, let's say if you want to get a data or output from the two different set of tables. And if you want only the common elements in the both the tables. So in that case, you can just use the inner join, right? So get those entries, whatever are valid, and then you can display the data back to the user. We need to see that we are minimizing the number of data transfers. So you can see from the right side arrow as well, right? So it is suggesting that if the result set what we are trying to achieve is initially used to be large. So now we need to keep the result set small. The next one also, if you see, there is a bulky arrow which is showing that we used to transfer a lot of data, but now we are suggesting that you need to minimize the amount of transfer data. And similarly, we need to minimize the number of database accesses as well. And the next one, what we have is we need to minimize the search overhead. So what is the search overhead? So whenever you are trying to do a search, so let's say you have a sales order. So obviously, when you want to give the user of feasibility to access that sales order, you provide a search, right? So if he has the sales order handy, you can just put in the sales order, and you'll get only the details relevant to that sales order. So we need to also consider the search overhead issues what we may face. So right, we need to minimize the search overhead. How can we do that? So we can use the index fields in the where clause instead of using only the fields which are not necessary. Wherever the fields where the index is done, if we use those index fields in the where clause, so this search overhead will be minimized. And also one more thing we need to understand is when accessing these database tables or databases, right, we need to always ensure that the correct index is being used, because index plays a key role when you're trying to do a search on top of a database table, right? So we need to be sure that when you're trying to access a database table, always ensure that the correct index is being used so that your selection, what you're doing is optimized and it gives the execution fast. And also the next thing what we need to see is we need to keep the unnecessary load away from the database. So what is this unnecessary load means on the database, right? So it's like buffering. So we need to reduce the database load by doing a buffering. If you just bring in the concept of buffering, right? So once the data is buffered, there is no need for you to go and reach out to your database table every time. Whenever you do a query, right? You can get the data from the buffer. And one more thing is we also need to avoid the repeated database access as well. So there is no need for you to just access the database each and every time, right? So we can eradicate all these things so that we give the space of DB by reducing some load. To avoid executing the same select multiple times, right? So let's say you have a requirement where you write a long report of around 1,000 plus lines, right? So there, instead of just putting or reusing this data from the internal tables, you generally write or forgot that you wrote the select statement at the top, and you again write a new select statement. So what we are doing is we are actually duplicating the same select statement multiple times in a report. So to avoid executing the same selection multiple statements, an internal table of type hashed can also be used to improve performance. So you can use a hashed type of internal table, which actually improves the performance of your database hits. And we also see a few other things. So we have discussed the key points around this 5 guidelines. So these are like a golden rules for the OpenSQL, right? So I just want to reiterate them once again so that because these things we'll consider when you're trying on S4HANA, because if you have a report, let's say you have a report which you have run it in traditional ERP and you did not do anything of these corrections or did not follow these guided performances. And if you try to run the same report in ABAP and HANA, you will not see much improvement in the execution time of a report because we did not follow the guidelines, what we need to follow in terms of doing the performance optimization, right? So we need to understand these points very clearly, right? So as we understood earlier, right? So we need to select as few fields as possible, especially from the tables in the column store. Whatever the columns you require, just pick or select only those columns. Avoid unpacking columns unnecessarily. Similarly, how can we minimize the number of database access? Avoid unpacking the same columns or tables unnecessarily. Right? So whenever you don't need this kind of activity, right? So don't just go and hit it there. So instead, just pull the data based on the requirement what you have. Like you need to select all rows and columns in one SQL statement, right? So we need to use also the mass processing wherever is possible. So when I say mass processing, so just don't go and write the same select query multiple times. And whenever, whatever columns you need, just pick only those columns. And how can we minimize the search overhead? In the where clauses, don't use the non-indexed fields. Always go and use the indexed fields. So which gives us the full effect of the S/4HANA system. And the next thing is, we also need to keep the unnecessary load from the database. We talked about if you reduce this unnecessary load from the database, it gives the database some space where it takes to analyze the most important calculation, the most important transaction which is happening on the server. Right? So what SAP HANA has done is, or does is, so it will push the data intensive calculation to S/4HANA. If you recall our last session, right? So that's where the core to data paradigm comes into the picture. So previously, when you write a select statement, so the request goes to the database, gets the data back onto the application server. And if you're trying to do a sum, it does all those calculations on the application server only. With the introduction of SAP HANA, so we are actually trying to push these calculations onto HANA so that we are reducing the load on the database as well as the application server, right? So the calculation or aggregation are very efficient in S/4HANA. It's a key point to S/4HANA. That's where we are pushing the calculations to be happen. Okay? So these activities significantly reduces the data transfer adds or the data transfer load to the database, which used to happen previously, which actually gives us the performance gain to the final application or a report. Those are the guidelines we need to keep in mind when you started working on this performance optimization. Now we'll jump to the next topic. We'll go to the next topic. Before that, I want to show you one thing here. So before going to the next topic, so we'll just have a quick look at the ABAP programming SQL statements. So you would have a fair idea of all the statements, but I want to just give you a heads up on this particular statements before we jump to the next topic, because next topic is all about OpenSQL, NateSQL. What is the difference between these two? And from there, we slowly go to the SQL script concept. So I would like to have a brush up of this SQL statements topic before we go to the next slide. Right. So the agenda of this particular slide is, so we talk about the database tables, the usage of the select statement on the wait clause, right? And we also talk about the select single statement. And we also see the order by addition to the particular select statement. And we will see retrieving, how we can retrieve the individual columns, and so on and so forth. If you see here, whenever you just put in any table, let's say you go to SE11 transaction or SE16 transaction, and if you just put this S-flight table, and if you execute it, right, you'll get a screen called data browser. We call it as a data browser, which is, we can see with the SE16, right? So if you see whatever the table you are seeing, it is the data which is saved inside this S-flight table. And the columns which are highlighted in the blue are the key fields, or we can call this the key index fields. Okay. The key fields are the fields which are highlighted in blue for this particular table. So if you see this table, so whatever columns you can see here, MENDT, RID, CONID, FL8, and price side. So this is the table what you can see. The table is S-flight, and these are the columns which are there inside the table, right? When I'm trying to write a test program, let's say I'm writing a program called ZDemo, right? So here, if you see what I have done is I have just created select star from S-flight, right? And I have wrote a simple program. I'm not doing anything. I just did a select star on the entire table. And I'm just printing only the 3 columns data. This is what I have done in this year. So instead of doing that, right? Instead of doing that, how can we restrict the data selection using the where clause, right? So if you see here, I have pushed the entire data here. So the first step is, I don't know the conditions. I wrote a select star statement, got the entire data and displayed it on the report. Now I want to put a small where condition where based on the char ID, I want to print some data. Right. So what I have done here, after select star, I have added a where condition and said char ID AA. Right. After that, I'll just try the state statement with the right statements here. Right. And as you know, this particular where condition has different set of comparison operators we can use, right? You can use the below operators. Obviously, you should be knowing, but I just want to have a quick recap of that one as well. You can use equal to, not equal to, less than, rather than, everything. Based on your conditions, you can write inside the where condition. This is how we can restrict the data selection using where clause. And if you are trying to retrieve a single record, based on different set of where conditions, right? Because if you see here, we are using a where condition where we are doing char ID on AA and the can ID 0017 and FL date. Obviously, with this combination, we'll have only one record, right? So in those cases, instead of using select star, we would suggest you to use select single star because we are trying to retrieve a single record. Even if you see here, when you are also doing this select access, so you can also use a keyword called up to one rows. Right? Even if you are not using the select star, I would suggest you to go select single. But if you are comfortable using select star, you can also use up to one rows. So what it does is, even if it does a select star, it only gets only one record. This is also one thing you can use, right? And if you want to retrieve the records in sequence, let's say in the ascending order of a primary key, let's say I have executed this report and I want to get the records in the order of the flight date, which means in the ascending order. So what I can do is write the same statements, and you need to use a keyword called order by. And if you use the keyword called order by, followed by the primary key for which you want the order of sequence. Right? In the below example, you can see we after the select star where condition, we have written the order by. After that, we have provided the relevant key fields, con ID and FL data. Right? So these two fields will actually, based on these two fields, whatever they are given, the data will be ordered or sorted out and will be displayed to the end user. Good. And we can also retrieve using individual columns. So there is no need for you to just put select star and then try to filter it out. What you can also do is, instead of getting all the columns from the table, you can just write the column name, right, and put it inside into your work area or any field, and you should be able to use it. So it is like we are trying to retrieve only the data from an individual column perspective. This is how we can do it. Here, if you see here, I am doing a select into a table. So let me know where the field is. Right? So you can see this is how we generally define a structure, right? And I have defined all the data fields. And here I wrote two forms, right? Get data and then display data. So if I go to the get data, you can see here, I wrote a select where I have provided all the fields or the columns which are required to me, and I'm pushing it to the table I_flight. So this is the table, or this is how we can push the data, whatever we get from the database, into our internal table. Right? Once you put it, you should be able to use it here. So once I got the table data inside my internal table, right? At the below you can see inside another form, I'm trying to loop the data into a work area. I'm trying to print the relevant carry quantity and the FL. Right? This is how I'm displaying the data. And obviously, when we are doing those kind of searches, right? So whatever the search you do on type of data or whatever the data you are trying to pull from the database, you'll have the duplicates. When I say duplicates, it's not in terms of the data, what is stored, in terms of the char IDs, right? So to eradicate those things, we can also use select distinct. So if you use this distinct keyword, right? So what it does is whatever the duplicates you have inside the data, those will be excluded and only the relevant output will be displayed back to the users. Got it? So you can use select distinct. And these are the important things what we will use a lot when you are working on the CDS concepts, which will be coming in the next sessions, right? So these aggregate functions gives you a boost of performance to your application, right? So we have these aggregate functions called count, max, min. We have so many. We'll see in the coming sessions, but these are the few aggregate expressions what we have. If you want to get the max value of a price column, right? So if you use the max of that max keyword followed by the price column, you can get that particular value. These we count, max, min, sum, we call those as aggregate expressions. Okay, that's all for the intro, guys, which is the classical OpenSQL and its limitations, right? So before we jump back to the, okay, yeah, I will first cover this one and then I'll talk about the references, okay? So we'll talk about what is the classic OpenSQL and what are the different limitations we have, okay? We'll talk about what is the standard SQL and the database integrations in the ABAP. And we also talk about what is OpenSQL, NetSQL, and the interface. And we also see the limitations what we have. Right? So what is a standard SQL? So this is not specific to SAP itself. So it is like we will be talking about more generalized SQL statements what we use. So SQL means it's a structured query language. So this language is used for accessing a database management system, DBMS system. So whatever the database you take MaxDB, MS SQL, Oracle, right, whatever the database management you are working on. So this is the language we use to access the data from that particular database management system, right? So this standard SQL is much more than an OpenSQL. So we'll see what that OpenSQL is on in the coming slides. Right. So this particular standard SQL is very standardized. So because we are not using this from last couple of years or so, this is standardized and we are using this from ages, right? And this particular standard SQL has 3 sub-languages, right? What does this particular standard query language have? This has 3 sub-languages. The first one is a data manipulation language. The second one is the data definition language. And the third one is the data control language. Right. So I'll just give a glimpse of what this is here, because we will be discussing this more once again when we are talking with the CDS concepts. So data manipulation language. So if you want to do any manipulation in terms of data, right? So when you are trying to do manipulation in terms of data, we use this particular concept of data manipulation language, right? So if you're trying to define a data, if you are trying to create a table, right? So those kind of data definitions, we use this data definition language. And if you want to do or put some authorization checks on top of a view or a database table, so we use the data control language. It is to control your view or table, whatever you have created. Okay. Yeah, here you can see. So data manipulation statements are mainly, we'll use this particular language when we want to manipulate the data, right? If you want to do a select, insert, update query, we generally use these statements. Like I said, data definition is like when you want to create or manage the database tables, create, alter, drop comes into those particular statements. And the DCL is more to take the authorization and put a control on the events, whatever we have created. Right. So what are the different database integrations we have in terms of ABAP? Right. So the SQL variant, which is known to ABAP programmers, is called OpenSQL. So whatever the language we are using when you're trying to work as an ABAP developer on top of a SAP system is OpenSQL language. Okay. So this particular OpenSQL covers only a small fraction of the SQL language. This particular SQL language, whatever we are using on top of AS ABAP system, covers only a fraction of the SQL language. It covers only a small part of the DML sub-language. So you can see here, if you try to recall, it covers only small part of the DML language. So if you write a business application, right? So if you write a business application, there is always a database on the backend, irrespective of the technology. You try to build any application in any language, right? So obviously there will be a database on the backend. So here also, as we know, R3 uses a database too, right? SAP uses the standard databases like Oracle, IBM, MS SQL, right? If we have a database on the backend, it is inevitable that we must use SQL, because that's what we understood, right? To talk with any database, we need to have this SQL. So SAP uses this SQL to do the select, insert, and update the data inside the database. However, the problem is that if you use different databases, your code, whatever it is, whether ABAP or not SQL, can vary, right? So in that particular situation, although the programmers tend to use the standard SQL, which is valid for all the databases, the problem sometimes occurs to switch one database to other database, right? So obviously we know. So if you use a standard SQL and you used to use Oracle, and suddenly your organization want to change the database from Oracle to MS SQL, right? So it causes an issue, right? So what are the code you have built on top of it will not work. So just to eradicate that particular path, SAP has invented a way to solve this problem, which they call it as an open SQL. Right? So in the ABAP programming language, we generally use two types of SQLs. One is a native SQL, and the second one is an open SQL. So open SQL allows developers to control SQL statements directly. Okay? Open SQL allows developers to control the SQL statements directly. OpenSQL encapsulates the semantics, whatever the semantics we have in terms of the statement execution, the parameter binding, and whatever the results we are trying to fetch, right, which are provided by the each database, or will be taken care by this OpenSQL. So it is not at all mattered what the vendor is or who the vendor is. The operations performed with the OpenSQL translate directly to the primitive operations provided by each database. So the conversion, whatever you are doing, right, so it happens in the backend automatically. There is no need for you to think or understand what your underlying database is when you start trying to build a report or a program, because OpenSQL takes care of all those conversions. So to avoid incompatibilities between different database tables, and also to make ABAP programs independent of the database systems in use, SAP has created a set of separate SQL statements, and they named it as an OpenSQL. Right? OpenSQL contains a subset of standard SQL statements, right, as well as few enhancements which are specific to SAP. So what are the different key statements which falls under this OpenSQL is the select statement, which we use to read the data from the database tables, insert, which add lines to these database tables, update, modify, delete, and we have also open cursor, fetch, close cursor, right? So if we want to read lines of database tables using the cursor, we can use those as well. So all the OpenSQL statements always fills the two system fields with the return codes. What are the two system fields? One is the size sub RC field, and the second one is the site DB count. Right? So after every OpenSQL statement, the system field size sub RC contains 0 if the operation was successful, and it will have a value other than 0 if it got failed. And the site DB count After an OpenSQL statement, the system field SciDB count contains the number of database lines processed. How many lines are there or records are present inside that query? This SciDB count holds the value of it. OpenSQL allows us to access all the database tables known to the SAP system, regardless of the database manufacturer. There is no need for you to bother who the vendor of the database is. Sometimes, right, however, we may want to use database-specific SQL statements called native SQL. Right? So SAP's the native SQL statement accesses the database directly. Right? So if you see here, if you see at the bottom, we have other DB, we have DB for ABAP. Right? So this is the architecture, what you can see. So when you're trying to build an application, you can use these two kind of SQL statements inside your program. Either you can use OpenSQL or native SQL. If you use OpenSQL, so these are the different things. Don't try to look at it. If you use OpenSQL, so there is no need for you to do a conversion. Just write the OpenSQL statements in your application, and the conversion happens internally, and you'll be able to get the data. And it is not tied to any database vendor. And your report will definitely work even if your organization changes the backend database of your SAP server. You can see here, we'll be having an important library called database specific library. Actually, this particular library translates the OpenSQL into native SQL in the backend. It connects to the database, and different remote database are possible with multiple DB clients. Right? So if you have multiple DB clients, you can also create different multiple sessions just to interact with them. And this is how an OpenSQL to native SQL translation happens. Right? If you write a statement called select carry quantity FLA from SFlight in the front end. So the left side is the OpenSQL statement what you wrote in your program. Right? Select from SFlight into corresponding tables. You wrote all this stuff. And if you try to execute it, and if you take the SQL trace, what happens in the backend is whatever the OpenSQL query you wrote, it is converted into the query like this. So you can see the right side one is the native SQL converted query. The format, everything will be different because that's a native SQL. And you can see the variables at the bottom here. So this is how it will be translated when you run or try to execute this program from an OpenSQL to native SQL in the backend. So what are the different limitations we have of this particular classical OpenSQL? Okay, with respect to the standard DMLs, so DMLs is the data manipulation language. So we don't have any case expressions. We don't have right outer joins. There are no unions. We can't write subqueries in select or from clauses, right? So these are the different limitations what we have, right? SAP HANA DBL, we will not be talking about it. We'll be just talking about the classical OpenSQL now. So these are the limitations what we have in terms of classical OpenSQL, right? So now we'll talk about also the native SQL. So native SQL allows us to use database-specific SQL statements in an ABAP program. This means that we can use database tables that are not administered by the ABAP dictionary. And therefore, the integration data, whatever we are trying to do, is not at all part of the R3 system. But this ABAP native SQL allows us to include this database-specific SQL operations, right, in an ABAP program, right? So most of the ABAP programs containing this data-specific SQL statements do not run with different databases. So that is the bottleneck what we have. So if you are using anywhere these native SQL statements, once your database got changed to another vendor, so that program will actually now be down because all the databases do not have a same set of operations. So if different databases are involved, we use OpenSQL. To execute this ABAP native SQL in ABAP program, we use a statement called exec. That's the key statement what we use, exec. OpenSQL allows us to access all the database tables available in the R3 system, regardless of the manufacturer. So to avoid conflicts between these database tables and to keep the ABAP programs independent from the database system, SAP has generated this particular set called OpenSQL. So if you create a table by using these database tools without ABAP dictionary, you are not able to use OpenSQL to reach this table. Let's say you did not use SC11 to create a table. You have created a table in a different way. Right? In that case, you'll not be able to access that particular table which got created in your program via OpenSQL. Right? We need to use native SQL to do that. Right? So native SQL statement bypass that particular R3 database interface, whatever SAP has built it. So there will not be any table logging, there will not be any synchronization with the database buffer. Nothing happens. So for this particular reason, we should, wherever possible, use OpenSQL to change database tables which are declared inside the ABAP dictionary. So in particular, the tables declared in the ABAP dictionary contain these log columns, right? So the native SQL does not take this information into account and may produce different results. So that's the reason why we need to use OpenSQL when you're trying to get the data or read the data from our database tables which are present inside this dictionary. But we'll have few scenarios where we need to get the data from the underlying database tables directly. So only in those conditions, we generally make use of this native SQL statements. So native SQL does not support this automatic client handling, and also we need to take care of all this client handling. Let's say you have a server and you have multiple clients on top of it, right? So native SQL does not take the client handling automatically. We need to tell that you need to hit this particular client to get the data. To ensure that the transactions in the other system are consistent, we should not use any statements like this commit rollback, right? And all these statements we cannot use, right? So we use a set of commit statements where we try to run the program, right? Similarly, whatever we are trying to do from OpenSQL, we can also do the same with native SQL. We can transfer the values from ABAP fields to database. We can read the data from the database and process it in ABAP programs. But native SQL works without the administrative data of the database stored inside the dictionary. So we should always ensure that the ABAP data type and the type of database column are identical. So if you do not do that, our program will go to a dump. So what are the different advantages and disadvantages we have with this native SQL then, right? So we'll talk about the advantages. So the tables are not declared in the ABAP dictionary, which can be accessed, right? So they are underlying on your direct database directly. It will not be sitting on your data dictionary. And we need to use some of the special features which are supported for that SQL programming, right? So let's say if you have an Oracle DB at the back end, so we can use these passing hints to the Oracle optimizer. So we have percentage hints keyword, which actually will be working only if you have the DB or Oracle. If you have a MS SQL, if you try to use a particular command, it goes to your dump, right? And what are the different disadvantages what we have? So there will not be any syntax checks, right? So if you write a program, you'll have a button called syntax check at the top, right? If you use OpenSQL, and it tells you if there are any syntax errors. The main big drawback or disadvantage is what we'll have with this native SQL is that we cannot do the syntax checks, because whatever the code we are writing inside the exec and the exec statements. And if you even do a syntax check, it will not be considered. So you need to be very careful while writing your code using native SQL. And whatever the ABAP program which you have written using this data specific SQL statements will not run if the underlying database is changed. And we also understand that there is no automatic client handling for the client dependent tables. We need to take our utmost care when we are doing the migration in terms of database upgrades at the back end to the next levels. So these are the different things what we need to keep in mind when you are working on a native SQL. That's all in terms of this OpenSQL and native SQL. You can take that, but it does not mean that you cannot use native SQL if you are working on ABAP system. You can use it, and we will use it in few scenarios. Because if you want to, because there are few requirements where we need to directly access the database tables, not the tables which we create in the ABAP dictionary, the tables which we create at the OS level. So if you want to access those kind of tables, we definitely need to use native SQL in our ABAP program. Then you'll go to our next topic, which is the enhanced OpenSQL. So why we are calling, or why SAP has enhanced this OpenSQL, we'll see, because we saw there are a few limitations what we have in terms of OpenSQL, right? So SAP saw that and they have enhanced this OpenSQL. And what is the SAP's motivation for this? And what is the new syntax of this OpenSQL? And what are the different new features we'll be getting as part of this OpenSQL? And we'll also see different other things as well going on. So let's see what is the motivation for this enhanced OpenSQL, right? So this particular slide will be more in terms of the database, but just try to understand the key concept inside it. So before talking on this slide, I want to just walk you through a few other things, right? So in the context of HANA, right? So with 7.4, SAP just not introduced the connectivity to HANA, but it also introduced the new syntax to ABAP. So ABAP developers who has worked on these reports, FMs, they need to understand this new syntax, whatever they have brought in, right? The common questions are, so, okay, SAP brought in these new syntaxes, but common questions for a developer is, right? So will the old syntax, let's say, on top of a 7.6, 7.4 system, if we write the code using the old syntax, will it work or not, right? Obviously, it will work. So, but why SAP has brought in this new syntax is for the performance implementations only, okay? The new version, whatever they brought in, it's like a more advanced version of coding, and it has a little performance improvement, right? It follows all those industry best practices. So this OpenSQL is the only DB abstraction layer which defines a common semantic for all these SAP supported database, right? So what are the limitations we used to have before SAP brought in this enhanced OpenSQL, which is less than 7.4 SP05, right? So we don't have any expressions, we have very limited join types, and we don't have union and union all at all. And we have few more other restrictions, right? So what they have done is they want to minimize those limitations. So from that particular 7.4 version, SAP has brought in this enhanced OpenSQL. And slowly what they have done is, in the next versions, they have standardized this OpenSQL, and finally they are trying to remove all those limitations what we used to have, and they are slowly taking this OpenSQL almost equal to reach the standard SQL. That means each and every statement, whatever the standard SQL used to have, will be having in OpenSQL as well. That's what SAP is trying to aim at, so that you can use all type of joins, you can use all the unions, you can use all the expressions. That's what they are trying to aim at. So they are more trying to get more standard SQL features in the OpenSQL for HANA and other database statements. That's what the motivation is. And if you see the new OpenSQL syntax in ABAP 7.4 SP05, right? So the screenshot which you're seeing above, right? So where it says select carry con ID from SBook into table LT underscore bookings where customer is equal to something. That is an old OpenSQL syntax. So it is a blank separated column list. So we used to give space between the columns when you're trying to write a select query, right? And there is no marking of ABAP variables required. If you see below, that's the new open syntax what SAP has brought in. So now, similar to the native SQL, what we do is we will be writing a comma separated column list here. Instead of space, right? Instead of space, we use a comma now. Instead of space, we use a comma now. It's a comma separated column list. And the ABAP variables are escaped with the @ character. And the ABAP variables are escaped with the ABAP character. Got it? So just try to understand these concepts. Anyways, we'll be writing few programs using OpenSQL syntax, and then I'll be trying to convert them to a new OpenSQL syntax to show you how we need to change and how they'll work. This is how we used to change if you want to write a code in the OpenSQL syntax. It's a bit of, like say, jump to the way how we used to write the code, but it is pretty much reasonable. Okay, instead of space, we need to use commas, and instead of declaring all those variables, we need to now mark those escape characters. And if you see the below statement here, right? So into clause at the end. So we wrote a into clause by saying into table at the rate LT underscore bookings up to 100 rows, right? So for the consistency, what we wrote is we can put this up to rows we have added after this table so that we get only the data whatever we are trying to aim at. And the keyword fields are also here changed. So if you see here, we can exchange the order of field list and the from clause. There is no need for you to go in a specific order. So the from clause first results in the code completion friendly syntax. So we can write a select star from SBook where we can say fields are, these are the fields what we need. You can write a where statement and you can pull everything inside an internal table. What are the different new features we got in terms of this OpenSQL? So we got something like SQL case and all. So I'll show you everything when you're writing a sample programs, but just try to grasp the steps here. Right? We'll use this SQL case and the coalesce functions, right? And we got these arithmetic functions with operators, right? And here, if you see here, right, I can use these functions, floor, seal, all those functions I can use. I can use a case statement inside the program, and I can use a cast statement. We can do this type conversion, right, with cast. I can do it here. And also, I'm able to use this arithmetic operations in terms of the variables, right? And I can also use these arithmetic functions like floor, seal, and all. And I have a few more things. I think these are the functions which we have used, right? Along with that, we can also use this string concatenation with the ampersand, and we can also use various other functions as well inside this newly brought in features of OpenSQL. What are the different limitations which were removed with this enhanced or the new features of SQL what SAP has brought in? Now the right outer join is supported. So previously you can use inner join, left outer join, everything, but we do not have a right outer join earlier. But now with this enhancement, they have removed the limitation of right outer join. So you should now be able to use this right outer join and use brackets in joins expression. So we need to use these brackets when you're writing the joins expressions, right? So you need to use those bracketing, right? So to remove this implicit bracketing, we need to use those brackets in joins, but now needed. And the on conditions are also extended, right? So if you try to see whenever you are writing those on conditions, right? So there is no field of the right table required in the on table now. So there is no longer limited to the equi-joins. Whatever the joins we do, it's all open now. So you just write it like what you write in a normal SQL statements, right? We have this implicit flight handling as well. And the maximum number of tables in joins also increased. Okay, and also the maximum number of the subqueries also increased to 50. Those are the limitations what they have brought in terms of this newly enhanced ABAP syntax. And they have also now started supporting the union and union all, right? So we understand what is inner join, union all, right? So whatever the fields which are common in those two tables, everything will be brought in and dumped down for us, right? That's one of the things what they have brought in. So if you see here, they wrote a select statement from a table, right? And they did some casting, and they did a union all on another select statement. If you see here, they did a union all and a select statement. So union all command is equal to union command. Both are one and the same, except that union all selects all the values. Okay, how we can say is that the difference between union and the union all is that union all will not eliminate the duplicate rows or the duplicate records. Instead, it just pulls all the rows from all the tables fitting our query needs and combines them into a table and just gives it back. Right? So union all selects all the values. Right? So only difference is between this union all is that union all will not duplicate the duplicate rows, whereas union does. That's the one difference what we have. Right? This union all and union all is now supported with 7. Greater than 7.4 onwards. Okay, guys. So that's all for today. Hope if we get the server tomorrow, we'll be covering all these examples hands-on on the server, because the next topic is CDS views. So I just don't want to start CDS views earlier, right? So I want to cover those HANA topics, HANA models, and from there I want to tell you why SAP has went into using SQL script, even they have this information models, which is attribute views and all the stuff, right? So until unless we saw how they run, we can't understand the disadvantages, right? So I'll just give it a pause here. So once we cover those HANA information models and the next set of sample programs related to the new syntax, then we'll talk about SQL script, right? And once we understand the SQL script, then we will go to the CDS part.
All right, let's test your knowledge. Here's a question for you. Which of the following statements is true about SAP ABAP on HANA? Option A, it is a separate programming language from ABAP. Option B, it can only run on SAP HANA databases. Option C, it introduces new programming concepts like CDS. Option D, it is not compatible with traditional ABAP programs. Take a moment to think, and when you are ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck! Type the correct answer in the comment section. Hey there, ready to dive into the world of SAP ABAP programming and SAP ABAP on HANA? Our course is your ticket to mastering these crucial skills. Take it at your own pace right here on our platform. In this course, we'll unravel the mysteries of SAP ABAP. It's like having a super handy toolbox for planning and managing supplies, ensuring everything flows smoothly from production to delivery. We've got you covered from the basics to advanced techniques. Crafted by seasoned experts, this course is packed with knowledge you won't find anywhere else. Your instructors, top-notch pros with years of experience. They're here to guide you every step of the way and clear up any doubts you may have. But don't just take our word for it. Our students rave about how helpful this course is. People just like you have found immense value in what we offer. And the best part, it's incredibly affordable. This amazing opportunity to level up your skills won't break the bank. Ready to become a SAP ABAP wizard? Enroll now on our page. For more details, head over to ZaranTech's website.
Okay, good morning, good evening, everyone. So if you try to recall what are the topics we have covered in our previous sessions. So we started with HANA. We saw what is the information model, what are the different types of views we have. And after that, we also saw what is the tool we need to use, like HANA Studio, to develop, right? And also we had a look at what are the different things we need to do if you are working on a upgrade or migration project of ABAP HANA and all the stuff, right? So today we'll try to do some hands-on in terms of HANA information models. Like we'll see how we can log into HANA Studio, how we can create those information models, what we are talking about. So this is how a HANA Studio looks like. Okay. So this is how a HANA Studio looks like. Let me try to reopen if you want. I'll just click on exit. So this is how the icon looks like. Just click on that one. If you try to recall, as I said, the initial sessions, right? So if you see what this SAP HANA Studio is, it is built on top of Eclipse. So you can see it is built on top of Eclipse as a base platform, and SAP has put in all these SAP related HANA related tools on top of it, right? So this is basically Eclipse. On top of it, SAP has built its own wrapper so that it supports all these HANA related modules. So how can we log into this system, or how we can add this system, right? So let me show you. So if you go to this particular screen, right, called systems, and if you click this small icon at the top, if you click on that one, it will ask you for the host name, instance name, everything. So you just provide, okay, let me try to, okay. The host name is SAP. You will have the instance number 00, say, and if you say next, right, so it will be asking you for the database user. So this is not your ECC user. So you'll be given something called a database user. Just put in this database user details. And if you just click on finish, the system will be added here. This is how, or this is the first step, what you need to do to add your HANA system into your HANA database. So the once we see the system in the green means it is running good and everything is looking good. Okay. Once you see the system, just click on this small arrow. And one more thing is, to do all these things, you need to click on this icon called Open Perspective, and you need to select HANA Development. So once you select HANA Development, these are all the things you can see in the Systems tab. Open this particular HANADB server, and you'll see a few folders here, right? We'll have catalog, we'll have provision, we'll have a content, right? We already discussed what each folder does, right? What is the use of each folder, what catalog does, what content stores, and what security stores, right? So today we'll start with creating information models, right? So I'm in the system. Sorry, I'm in the SAP HANA Studio, and I have logged into the HANA system. So what I'll do now is I'll create my own package, right? Because as we know, even if you start working on your ABAP projects, right? So we initially create a package inside which we keep all our development objects, so that all our development objects related to that particular project sits in a single place, so that it will be easy for us to identify. Right? So now here also I'll follow the same process. So I'll go to the content. Right? I'll just click on this content folder, and I'll right click, new, and say package. Right? I'll just give the name. A package is simply a collection of design time objects, right? So as we know, it serves three purposes. Any package, wherever you create, whatever you create, right? So that package generally serves three purposes. It allows grouping of development content, and it also gives us the control who can develop in a particular package. It's like we can put some security and the authorization levels, where in which there is, it's like no other user except the ones which we have given those package privileges to can create those objects inside it, right? We can control everything from there. And also package provides a namespace to artifacts, right? What does that mean, right? So suppose we create a view called say v_mara, right? And one of my other colleague who is working on the same project and on the same HANA system can also create a view with the same name as v_mara, provided, right, he or she is developing in another package. So package plays a key role here. You can create same view with same names, but in a different packages, right? So when the runtime object is created, the name of the runtime objects contain like the package name / your object name. So that's important, right? That's where you'll not get this duplication of names when you see in the HANA system. It's all depends on the package what we are creating, right? Good. Let me give the package some name. I'll give g_December 21. And I'll say, okay. So you can see the below here, the package which I just created. Right? Now we'll start with creating an attribute view. Let's see how we can create an attribute view here. Just click on the package, right click. And if you see in the view, you can see different options, right? So we'll first start with attribute view. Right? Just click on this attribute view. And here, let me give some name. So I'll say, I'll use this business partners. I'll say AT_business_ partners. Right? This is a attribute view which will be creating for the business partners, or let's say to display those business partners, right? So here you'll see different types here. So we'll go one by one, right? If you try to recall our other session, we talked about this, but for now we'll be using the standard subtype. Just say finish, and you'll see, okay, you'll see something like this, right? So this is where actually we'll be doing all our development part or modeling part. Okay. So let's start with data foundation. Okay. So what is the data foundation? It's where actually we pull all the tables element to it. So let's say if I want to build this view, so what are the different tables I want to have and I want to add, right? So if you just take your mouse pointer onto this data foundation, you'll see a small green plus icon, right? Just click on that icon. And here you can do the search of the tables. I'll just use SNWD_BPA. This is a standard table. So I'll use this SNWD_BPA table. Okay. We should see the table from SAP HANA DB. Okay, I'm not able to see this HANA DB, but let me try with this one. SNWD_BPA. Right. I'll just select this table, and my table is inside this particular data foundation. Next, we'll add one more table, and we'll say SNWD_AD. It is an address table, right? It is an address table. Just add that particular table as well. We have added two tables to our data foundation. So if you just click on this, let's say you take a Mara table, you can see Mara table, right? So whatever the table you build, or sorry, whatever the table you want as, along with the combination of standard and the custom tables, yes, you can see everything here. And the one which you are using, it's a standard table. The SNW, this is the tables what we generally use, what we get from our EPM Debo package. Because it contains all the test data, so that's why I use these tables for trainings, so that the data exists to show the students how it looks like and how the data looks like. Okay, so once we put in all these tables, right, so we'll do the next step, which we call it as a mapping, right? So once the tables are pulled inside it, we'll do something called a mapping. So the first and foremost thing in HANA, what we need to do is we need to do a client-to-client mapping, because like in SAP ABAP, the client is not auto-handled, so we need to map those client fields as we are working at the DB level, because HANA, we are at a HANA layer and we are working at a DB level. So we definitely need to tell the system what client it needs to use. So joining a client is a mandatory thing what we need to do when you're building a view. And here I'll add this address GUID to node key. Because I know the relationship between these tables. That's why I'm just going in and adding it. So if you don't know that, you need to open that particular view, right? Have a look at it, try to understand what this field does, and open the second view what the field does, and you need to map those key or common fields. Hope you got my point, right? So see how this is what we have just done, and see how easy it is to create an information model, right? So we'll see which fields I want to display. I just did a mapping. Now I want to see something, right? So why do we build a view? So because in the view we want to see some columns which display some data. Right. So what is the use of creating a view actually, right? So there are a few things which we need to understand. So the view actually hides the complexity of the query. If you just execute a view, it gives you the data. No one knows what is running behind your view, right? So it hides the complexity of the query, and it also gives us a security, right? So imagine there is a table called employee table, right? And it has employee name, age, and all this stuff. Right? And if we want to expose the data, to outside world, to any application, right? We cannot just expose the entire table, because the same table will have the employee's salary, right? The employee birth date. So those are all kind of a sensitive information to others. So others cannot see this data. So generally what we do is we create views on top of the database tables and suppress the files which are not necessary. Right? And then we add the columns whichever are needed in the view, so that only those columns and the data relevant to those columns are displayed to the outside world. Right? Good. So how can we add the columns inside the view? So what you can do is you can just click on the fields. When I say click on the fields, if you take your mouse pointer onto this fields, you'll get this hand symbol. Just click. If it turns to orange, you can see to the right side, you can see the particular column. I'll select node key. I'll select some PPID. And here I'll select something, company name. And from here I'll select city and country. Okay, that's fine. Right? So now if you to the right side, whatever the columns we have selected, right, everything you can see in the column list in the output. So the purpose of this particular attribute view is to expose the master data. So if you see here, the tables, whatever we are using, these are the master tables. So the purpose of this attribute view is to expose the master data. Because it is processed by the join engine in HANA, typically to obtain master data, generally, if you are working in ABAP layer, right? So if you want to get the data from two tables, generally go for doing a join. So as we are working at the HANA layer and it is using the join engine in this particular layer, it is mandatory to have at least one key column defined to attribute view, right? So without which we will not be able to create the attribute view. Got it? So on the other hand, we can add any number of columns. So one field is definitely a mandatory, at least one key, right? But if you want to have more than one key, you can definitely add it. Now I'll try to activate the view. Okay, let's see what happens. Let me save this and I'll activate this view. If you see at the bottom, our activation got failed, right? Why did this got failed? Because it's saying there is no attribute, no attribute has been specified as a key. As I said, this attribute view will look like should have at least one key, right? We did not put any key, that's why the activation got failed, right? Good. So how do we mark that key, right? So how do we mark a field as a key, right? Okay. So how can we mark a particular field as key, right? If you just click on this column, right? If you click on this column, if you scroll down, you'll see something called a key. You need to change that property. Okay, just click that field. If you change it to true, now you have added node underscore key as your node underscore field as your key. If you see here, okay, you have selected this key and we have added it as a key. So if I select this BPID, right, anyways, in the next coming sessions, we can do it. So if I can just change it to true, you can have, but having one key is a mandatory. It's not like that you definitely need to have, you can have multiple keys, but at least we need to have one key. It's like a primary key, yes. Clear? Now what I'll do is I have saved it. Now if I try to activate it, if you see now, activation is successful, right? So now, okay, we have built a view, we have successfully activated it, right? But how can I see the data and see my view is working or not? If you see at the top, right, you'll have something called data preview, right? If you just click on the data preview, and if you go to raw data, you can see all the data here. So whatever the columns you have added node underscore key, BP underscore ID, company underscore name, city and country. So these are the columns what we have added from two tables, right? And we have built a attribute view on top of it. So if you try to recall, right? So if you try to recall what happens if we activate a design time object, because AT underscore business partner, the attribute view, right? It's a design time object. So what happens when I did click on that activate button over there, right? In the back end, a runtime object is created. Okay. In the back end, a runtime object is created. And okay, good. Now a runtime object is created. And if you want to have a look at that runtime object, we'll not be using it, but just in case if you want to have a look at it, right? So what you can do is you can go to, We go to the sysbig folder. And here, let us search for the object that we have created a view, right? We should see the view here. If I don't have the access, I'll not be able to. We have used AT, right? Yeah. Yeah, looks like I don't have an access. If not, you should see it in your catalogs view. Okay, good. So if I click on the semantics and if I go to the view properties, right, this is where your actually column view will sit, right? So if I try to do a search, so because I am in sysbig, column views, Z badge. Okay, sorry, I think I said views, right? So the runtime objects will be in the column views. Z badge, yeah, I don't think I have access. Okay, I think there's a limitation here. Let me try to do a search. Z batch. Yeah, if you see here, this is what we have created. So this is the one which is created inside the sysbig is the runtime view. This is the runtime view which got generated, right? Which got generated after we created and activated the business view. What happens if you go and see in the create statement, you will see all those joins, whatever we have done. So this is what is the runtime object which got created in the backend. Now, if I just go to this SQL, if I go to SQL, right, and if I write a select star from this particular table, if I click on execute, you see whatever the data you saw when we executed in the data view, the same thing you can see when we try to execute this runtime object as well. We can see that the same data is coming like what we get from the design time object, even if we run the runtime object as well. Good. Now, I'll again go back to our attribute views. Now I'll create, right? Now I'll create one more attribute view. So how do we create it? Right click, new. I'll create an attribute for, this is another master data, right? So I'm creating another attribute view for this particular product tables. I'll say finish. And the same thing, I'll add a couple of master tables here related to products, SNWD underscore product. And I'll add one more table to display the text of this product, SNWD underscore. I think it is, let me try. Okay. Same thing, whatever we have done, the first and foremost thing to create is map client to client field. Okay. Client to client field. And then we'll add this description GUID to the node GUID. I think no description, just give me a second. I think, okay. And if you want to delete it, just select and say delete. The mapping will be deleted. Okay, description GUID should be mapped. And if you see here, so whatever I'm doing now, right? So I'm trying to do a mapping from description GUID to the parent key. Because I'm talking to the text, this join, what I'm doing, right? Whatever the join I'm doing should not be a referential join. By default, you'll get a referential join. Because I'm trying to just get only the text, right? And this table, whatever we are talking about, the text table is not a normal table, right? It's a text table where it stores all those descriptions. So I want the join to be a text join. Okay, I want this particular join to be a text join. This is how you can change the joins. We'll use different joins going on, but this is how you can change the type of a join when you are doing the mappings. We'll have, as we discussed, right, we'll have around 8 types of joins, which we use based on our requirement. Right? The text join is mainly used when we want to join a table with its corresponding text table, right? So this join allows us to make a relation inclusive of the inclusive of the login language. So what does that mean, right? Suppose if I log in using English language, it should show me automatically the product text in English. right? And if I log in using German language, it should automatically show the product testing in German, right? So that's the reason why we do this kind of a text joins. And we change it here. That's one way, and we can also change it directly here. Just select the event and change it to text join. Okay, these are the two ways how you can do a change of join type. Okay, if we double click, right, so you will get this particular screen. And when I changed to text join, right, when I change the join type to text join, we have to mandatorily specify which is the language column, right, which is the language column, and also which is a language column, right? So at runtime, what happens is when I run this automatically pass the language field, right? So now what I'll do one thing. So I'll not do anything. I just did a mapping, right? And directly I will try to select the output fields. So let's say we'll select node key, product ID. So I'll not do anything much. Once you take your mouse pointer onto this column fields, right? So you'll get this hand icon. Just click on that hand icon and it will be added in the column. Now if I save and activate it, it got failed. So let's see why it got failed. It is saying that no language column found for the join because we are doing a text join. Because whatever the text it needs to bring when we run this particular view, we need to tell the particular view that use this language when you're trying to get the data. That's why language is feel like a mandatory column which you need to select when you're trying to use this particular thing. And here I want to also cover a few things here. So which we saw, there are default folders which will be there inside the catalog, or we call it default schemas, right? We have _sys_big schema, which we just saw when we want to check for the runtime object, right? So this is mainly used to store the column views of all the activated objects in the HANA repository. Whatever the HANA objects we are trying to be designed and activated, all the runtime objects will be saved inside the sysbig schema. So when an object is created and activated, all these modeling views, stored procs, right? So runtime objects are saved under this particular sysbig schema. We have one more schema called sysbi schema. We have one more schema called sysbi schema. So this schema in HANA system stores table created for variables. We'll have something, we'll be creating going on few time dimensions and few physical variants and all. So all those things will be saved inside this sysbi schema. Do a check, right? So let's say, I think I don't have the sysbi schema. Yeah, tell me please. And one more thing is, if you see here, I also want to just cover this particular joins as well. If you see here, we have different types of joins, right? So we know inner, left outer, right outer text. So these are normal joins, but we have something called referential join here. So what is the difference between referential join and the inner join, right? So in the context of HANA view, inner join is a guaranteed join, as I said, right? So what does that mean? It means it is going to apply the join between the two tables by comparison based on the join conditions and then returns the values, right? But a referential join is a smart inner join. Whether the join will be applied or not at runtime, it depends on the select query we pass, right? So then the join will be ignored if the data is not selected. And if the data is not selected from both the tables, it simply ignores the join. It's like a smart join. Whereas inner join is like, if you have the data, it will do. And what happens is, in few cases, based on the scenarios and the data what we have, you need to cleverly select the join what is applicable or there, because there is a very good confusion among students when they go for using this referential and the inner joins. Okay? So just to recall, so referential inner join is what? Inner join is going to apply the join between two tables by comparison based on the join conditions and then returns the values. Whereas a referential join is a smart inner join. If there is no common data between these two tables, it simply, the join will be ignored and the data is not selected at all. So let's come back to this particular thing, and we'll try to solve this issue, right? Just come here, select the language. Okay, it got highlighted. Okay, I'm just checking this grayed out. Okay, select this language column and select the text here. Okay, and say okay. And now save it. No central table font, no attribute here. Oh, sorry, I did not specify the key, it seems. So select the key. Okay, now you see it got activated. I did not save it earlier. So now if you do the same thing, like if you click on this data preview, and if you go to raw data, you can see the view which we have built. See here, you see question marks. That means our nulls are generally showed as question mark in SAP HANA. Here, because it is not having clarity on the language what we have logged in, it is showing as a question mark and not showing as a text. Okay, if okay, let me try to go to one here, and if I see if I can edit. Yeah, it seems like it does not have much of access for me. But yeah, if you have the language field specified, right, you should be able to see the data what in terms of this text. Oh, sorry, text. Oh, yeah, sorry, it should select language. Sorry. Let me try to rerun it and see if this works. Oh, yeah, I think I still don't have access to the text, but yeah, language is the one which you need to select because it's a language column. We need to tell the system what language it needs to pick so that it gets the relevant text in that particular language. You can create anything, but as you know, right, we for the process ABAP. So let me try to create one package. It takes anything. I can batch test. It's not like a mandatory. You can just give, because this is at the database level. It's not your ABAP layer in which it restricts you from creating. Yeah, if you're working on ABAP from long time, right, you generally go with an intent of creating Z's. But yeah, you use whatever. Okay, so with respect to the naming conventions, we don't have any, but it all depends on your organization's rule set and the practice what they follow. Because in my organization, for a couple of clients, we use Z, whereas for a couple of clients, we use the project names directly at the HANA DB layer on use case of the customer. Okay, you can check with SC11. If not, what you can do is you can go here if you want, or else what you can do is you can do a search here. So let's say like how I did, right? You can either go to SC11 or you can, sorry, my this one is a bit slow. Let me go back to SysBig. And if I go to tables, and I'll search for the table where we are trying, right? SNWD underscore, let's say the product table itself, right? SNWD underscore product. Just select this table, okay? And you can see what are the columns you have, what are the indexes you have. You can see everything like you see in the SC11. And here, if you click on, you can see data preview also here. Okay, we are in the SysBig, right? Yeah, SysBig, you can just see the structure, right? But if you want to see the data, again, we can do it from here. Let me show you. So here you can see what are the different columns you have, right? What are the different indexes you have, everything you can see from here. I should see it here at the bottom of the table so that I can select data preview. I'm not able to see it here. Okay, let me try to filter it first. SNWD score PD. Yeah, I'm not able to do a filter because once I see the table, right? So, okay, once I see the table, if I just right click and if I say so data preview, we should be able to see it. And the same thing if you go to S11, and if you have a look at it also, you see the same set of data and everything will be the same. There's no need for you to go back to HANA SAP server to check. You can just do everything here on. Good. So now we'll try to talk about few things, right? So we have created two attribute views. We have created two attribute views. One is for product and one is for business partners, right? Now let's create an analytical view. So what is the use of an analytical view? Right? So analytical views are built for analytical purposes. So generally they are used in cases, or they are created when we want to develop a star schema. So when do we develop or create a star schema? If we want to join this master data with a different sets of transactions data to evaluate the analytic outcomes. So simply to say, if I want to get a total sales for product or per customer or average days of open invoice. So if I want to get all these contents or analytics, right? So we generally create an analytical view. So these views are processed by the OLAP engine. So let me do it. Okay, you see here, right? So we saw the runtime and all, right? So similarly, if we try to create a analytical view, this is very open. So key, you can also select it by clicking on the semantics and selecting the field here. Okay, that's the one way where we select that mapping and change, select the key. And this is the second way how we can do it also. Clear? So let's say if my company has so many sales orders, and I want to find out what are all the sales order line items and sales per customer per product, right? So which products are sold mostly in my company, and who is my top priority customer, and which country is giving me high sales for my products, and what is my top sales making currency. So if I want to find all these things, right? So generally, to answer those questions, whatever we are trying to address, we generally create an analytical views, right? So now we'll be now using the attributes views, whatever we have created in HANA. So we will be creating this particular attribute views, and then we'll be using those in the analytical views. How can we create an analytical view? Just select your package, right click, and say analytic package. So the first thing is I want to create an analytical view for my sales data. I'll say n_sales_data. Okay, I'll say finish. So this is what screen you will see. If you remember, in attribute view, we just saw semantics and data foundation, but here we got something new called star join. Now we'll add two tables here, like what we did for attribute view. So I'll add the sales order table, and I'll also add the sales order items table. Okay, I have added two tables here. The same thing, I'll map the client to client and node key to parent key, right? And here, because as you know, one sales order can have multiple line items, right? Multiple line items. So what I'll do here is I'll just click on this. I'll change my join to inner join, and we'll have something called a cardinality, right? So cardinality is like based on your request. So if I want to get a data from another table based on my parent record, so we use the cardinality, right? So if you see for one sales order, we'll have multiple line items. That's why we are choosing here 1 to n, because one sales order will have multiple sales items. In some cases where we'll have only 1-to-1 mapping, in that case we just go for 1-to-1. It all depends on your use case. N-to-1 is like for many entries in your first table, you'll have only one record in the second table. We generally go for N-to-1, right? N-to-M is also similar. If you have n number of records with n number of items. we go for entry. So in this case, we are going for 1 to n because for one sales order, we'll have multiple line items. And say validate join. Everything is good. Say okay. Right. Now we'll add the columns. I'll add the node key. We'll add a few more fields here. Okay, we'll add gross amount, currency code, buyer ID. We'll add all this inside here. We'll add the product grid because that's no product. We have product ID somewhere. Yeah, we'll add the product grid. Yeah, I think it should be good. So we have added few columns, right? So like in attribute view, we mark the key field as mandatory, right? In analytic view, it is mandatory to mark a measure. What is the measure? It's like a numeric field, right? Let's just keep in mind, we'll be selecting it soon, but just keep in mind. Like how we selected a key in attribute views, we should create, select or create a measures in analytics view. So now I'm clicking on the start join, right? If you see here, these are all the fields which we just selected, right? Now what I'll do is click on this plus icon after selecting the start join, and here I will add my attribute views. What is my attribute view? AT underscore product, which is this one. And I'll also add AT underscore business partners. This one. Here. Now, if you see, so we have two master tables and we have one transaction table, which we built. Okay. Good. So now what I will do is we'll try to do the mapping, right? So we'll try to map these fields. Where is this product is here? We'll try to map the buyer GUID to the company name. Buyer GUID to the company name. And the product GUID to the node key. The product GUID to the node key. Put it in the middle, we can just swap it like this. Clear? If you see here, we have something called node keys all around everywhere. So definitely when we do this, okay, let me try to save and activate. I am not telling you anything. So we just did the mapping. If you see here, measure cannot be identified. It is asking me to select a measure. Okay. Let's select one measure.
I have a question.
Just select here, and here you can select the measure whatever you want. Okay. So what we'll do is we'll select the gross amount because it's a numeric value. Gross amount, it's a numeric value. We'll select this one as a gross amount. Okay. So if you see here, you can select this gross amount type as measures. I'm selecting this gross amount, which is a numeric field as a measure to this particular view. Now I will save. And now if I activate it, it got activated successfully. And if I click on data preview, and if I go to raw data, okay, I did not get the results. Okay, let me go and check what happened wrong here. Okay, it's because of this. Yeah, it may be because of this node names. If you see node name, node underscore key is common in all these tables, right? Maybe it's where it got confused. So what we need to do is we have a node key which is giving a conflictor name. Okay, we'll change it here. So what we'll do is let me delete the star model ones. Just delete. Delete, we have a star model. Let me go back here. And now I'll just do the changes here. And node key, I'll change it to some. Let me go back to this. I'll change this node key. This is a product table, yeah, product underscore key. And I'll save and activate. Because we have all the node key names same, it is not able to get exact data. So similarly, I'll change. Okay, I got the everything. Now I'll go to the analytics view. Right here, now what I'll do is, so now I'll try to add those attributes here, AP underscore. Now we'll do the mapping like what we did. Okay. Buyer GUID to company name. Buyer GUID to company name. I think I need to restart this one. Let me restart this studio. Okay, now everything is good. Okay, now we'll do the mapping of what we are doing, right? So what I have did is I have mapped the product ID. Oh, sorry, this is what. Okay, we got the fields now. Right. So now we'll do the mapping what we are doing here. Right. Okay, seems like the fields and the data is wrong. What is the field SOSI? I think I need to go back to the tables to see what's going wrong. Let me open product to SO, right? Sales orders to product. We have a product ID and the node key here. Let me execute this. Yeah, I think the relationship is, I need to check the relationship between these two tables, right? Let me, okay, after I deleted, okay, give me one thing. Okay, guys, let me park it aside. Let me spend some time and try to check all these columns and all. I'll just repeat the same, or I'll tell you what mistake I would have done, because whenever we are working on these tables and models, right? So columns, you need to be sure that what are the key columns you want to use and which columns are equal. Because if you see, I need to map this product GUID to the product key here, right? So that's how I need to do the mapping. It seems something is missing here, or I did some mistake. Yeah, I think it takes some time. I need to study each and every table and column and see what would have went wrong. Okay.
Okay.
I just park it aside, but I'll tell you tomorrow what is the mistake I have done and how I have corrected it. Because until and unless we get the data right, we will not be able to do some analysis in the analytical view. Okay. I'm just parking this aside. We'll talk about it tomorrow once I find out and fix the errors, right? Good. So this is all about this analytical views, right? So if we simply do this kind of building the views and do some analytics on top of it, right? So we also, if you see here, okay, let me go here. So if you see here, we are trying to display the gross amount, right? We try to display the gross amount. But if you see the joints, whatever we have done, we are not talking about how we can handle the currencies, different currencies, what we get in terms of gross amount, right? Generally, it's not a good idea to do the total gross amount, which we get from different countries in different currencies, right? We should not do that, because whatever the report you are showing, it is obviously wrong, because you cannot just add different currencies what you get, because each currency will have different conversion rates, right? We cannot do that. So we must add the common currencies to get the right amount, right? How we can achieve that particular part in HANA, right? We have a concept called calculated columns, right? We have a concept called calculated columns, which takes care of those kind of activities in HANA, right? Now, what I'll do is we'll create something called a calculated column now for the gross amount. So how can we create a calculated column? Just select this folder, right click and say new calculated column. So once you do that, you'll get this particular screen or window. Just give some name to your calculated column, say gross underscore converted, because it's an amount. I want to do this in decimal. You can give anything. I'm just giving the standard lengths of a decimal fields, 15.2, and the column type should be a measure. Okay, the column type should be a measure, because this is a numeric field what we are talking about. Now we'll have something called an expression editor here, right? What you need to do is, if you scroll down and if you open this particular column list, you can see everything, right? So here what you need to do is you need to add that particular column for which you want to create a calculated column on top of it, right? So just drag this gross amount column and put it here. If it shows green, that means the syntax is valid. There is no issues for you to happen. Okay, I just added and created a column, but I want to apply the conversion on this particular measure, because without applying conversion, there is no use of this column for me, because I'm simply again showing the same gross amount value what I'm getting in this new column as well, right? So my intention is now to apply the currency conversion on top of this one, right? How can I do that? So you'll have something called a semantics tab just beside the expression tab. Just click on the semantics tab, right? And select the drop down, and you'll have something called amount with currency code. Because we are dealing with amounts with currency codes, we'll select that particular semantic type. You'll get this particular screen. Okay. We have selected amount with currency code, and then you can see this particular screen, right? Select these two, because we want the conversion to happen, and we also want the decimal shift to happen. Okay, these are the two things by default we generally select when we are trying to do a currency conversion. So what is the currency I want to convert? Right? To which currency I want to convert? So select the schema for currency conversion. It will be it will be the HANA DB schema, which is SAP S4H schema. And the next thing is, what is the client for the conversion table? So it will be the session client by default. There is no need for you to again enter. Okay. And what is your source currency? Right. So let's say I'm trying to display all my sales orders amounts, gross amount in EUR. Now my target currencies, I want to, sorry. Source currency is the one which we are trying to print it, right? Which is the, what is this? We have a column called currency code, right? Just select the currency code, which is our source currency, because this is the column which I'm trying to display the amounts. Now, what currency you want to convert all these into a common currency? To which common currency you want to convert all these existing gross amounts? So let's say my target currency is EUR. I want to convert into euros, right? And we have something called exchange type, right? We use M, which is the standard translation at an average rate. This is standard ones which we can use. This is the exchange rate what we use. Okay, and what is the conversion date you want to use? Let's say I want to use as of today. Okay, as of today, I want to do the conversion rate based on it. Clear? Good. And you'll have one more important thing at the bottom, which is called upon conversion failure. So here you'll have fail, set to null, and include. So in production systems, the field value will be failed, because if something goes wrong in the conversion, we don't want to update it and say everything is good, right? So in production, it should be fail if you're using it in a production system. But as we are in the development system or training, I'll just say ignore for now, because even if something goes wrong, there is nothing wrong going for me, right? I'll say okay. Right? Now, if I just save and activate, and if I try to see the raw data, now you'll see a new column called gross underscore converted. So this converted gross column will have all the amounts of gross amounts which are converted in the EUR, which is your common currency which you have just selected. Because what we are trying to do is we are building an analytical view inside which we are consuming two attribute views. Combination of all this, we are trying to create an analytic view out of it. Analysis on the questions what we have raised, like if we want to do the currency, what is the maximum gross amount, who is your top customer. To analyze all those things, we are trying to build an analytical view and see how we can analyze the data from there. Okay, I want to stop it here because I need to have the data, because before going to the next steps, I need to show you how the data looks like, because we did, if you see this particular gross column, right? So whatever we did, we just hard coded it. But now if we want to change it to a more of a dynamic way, right? I want to first show you how it used to be and then want to do a change. So by tomorrow, I'll try to fix this issue and then we'll continue from there.
All right, let's test your knowledge. Here's a question for you. What is the primary database management system used by SAP ABAP on HANA? Option A, Oracle. Option B, SQL Server. Option C, SAP HANA. Option D, IBM DB2. Take a moment to think, and when you are ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck. Type the correct answer in the comment section. Hey there, ready to dive into the world of SAP ABAP programming and SAP ABAP on HANA? Our course is your ticket to mastering these crucial skills. Take it at your own pace right here on our platform. In this course, we'll unravel the mysteries of SAP ABAP It's like having a super handy toolbox for planning and managing supplies, ensuring everything flows smoothly from production to delivery. We've got you covered from the basics to advanced techniques. Crafted by seasoned experts, this course is packed with knowledge you won't find anywhere else. Your instructors, top-notch pros with years of experience. They're here to guide you every step of the way and clear up any doubts you may have. But don't just take our word for it. Our students rave about how helpful this course is. People just like you have found immense value in what we offer. And the best part, it's incredibly affordable. This amazing opportunity to level up your skills won't break the bank. Ready to become a SAP ABAP wizard? Enroll now on our page. For more details, head over to ZaranTech's website.
We have tried to create calculation views, right? And also we have created a couple of analytical views, right? So we have created around 3 analytical views and we have created around 3 attribute views. So when we are trying to create a calculated view, we got an issue saying that we don't have the relevant access. For that, we have created the analytical privilege. So I have requested the system admin to give me the access. Let me see if I have the access so that we can add. And let me try to use it in the demand view and see what happens. Let me try to see the data preview of this one. Okay, good. Okay, so it thinks the analytical permission issue is not solved. So we'll just park this aside and we'll move forward and then we'll come back and see once we get the access. Okay. So if we click on this view properties, right, you can see something here called a column view name. So this is where, or this is what we use generally to do or write a SQL statements, right? So if I just copy this one, I'll just copy this one and okay, instead of this, we'll do this one. Okay, our analytical view is open. So what I'm trying to do here is I'm trying to copy the runtime name, right? Runtime column, I'm just copying this and now I'll try to see how I can call this from a general SQL queries, right? Because we saw we can consume this via using all the design term objects. But if you want to consume it via runtime parameters, how can we do that? Right. So for that, I am just clicking on this system user. And once you click on this SQL editor will get enabled. So if it is selected on any other tab or any other view, right? So you can just click on this SQL editor at the top, just click, it will open up SQL console. So here what I'm trying to do is, I'll just try to write a small query. I'll say, let me check on the columns as well. What are the columns we have here? Do we have the currency code? Gross amount. Okay, we have underscore gross underscore amount. Okay. What we'll do is I'll say dot sum of con underscore gross underscore amount as gross underscore amount. Let's say which of we have something called a date field which we created, right? Open dates. Let me check on that key field name. So dates underscore open. Okay. I'll say dates underscore open. This is a new syntax which I'm using. So once these two scenarios are done, we'll be talking about this new syntax and see how we can write a program out of it. Okay. Now I'll just paste this this thing, okay? And I'll also say underscore name. So if I just try to execute this one, right, just select this, and if here you can see execute, just select this one. Okay, let's see, I got some error. As I already did, this one is not a group by. Okay, let me try to show you this one. What is the name of the company column we have? We have company underscore name. Okay. Company underscore name. Okay, you see that. So you can see the output. Now what you're trying to see is, so what I did was I just wrote a query on the runtime object which just got created when we created the design time analytical view, right? So on top of it, I wrote a select query. I did the sum of all the converted gross amount values for that particular company name. And also I have done the open dates average of that particular days column from the particular view what I have created, and I'm doing a group by for the company name. So we'll see why or how I have used this particular new syntax, right? Sum inside the query and also as and also group by. So right, these we'll be talking about when we talk about the new syntax scenarios. But this is how we generally consume the created information views, or one of the way we consume this information views, whatever we have created on HANA layer inside a ABAP layer. Now here you can see the gross amount is in the common currency, right? And also the average open days, it is showing in decimals, right? But we can also easily round it off. So how can we round it off? Let's see. Let's go back to the SQL editor. And now here what I'll say is, instead of average, right, or before average, I'll use one more aggregate function, which I'll say round. Okay. I'll say round. Now, if you go back here, so if you remember the result, here we used to see and now decimal value set. So if you want to round it off, just say and execute again. Now you should see, just in case if you have any decimals, you should see are those values got rounded off. Okay. Or you can do the same for this gross amount. So let me show you for gross amount. Here also I can use ROUND, because this is amount we generally do not use, but just to show you how this round function works, I'm just doing it. So if you see here, all the decimals are gone now. Everything is rounded to its nearest integer, right? Good. Now we want to use the above data, right? We just got displayed in the ABAP layer. But the question here is how we can consume this particular data, whatever we are seeing at the HANA layer inside the ABAP layer. So what are the different things we need to do? Because whatever the views you are creating or what are the data you are able to see, you are all seeing on top of the HANA layer. We are not, or we did not enter the ABAP layer yet. How can we do that? So before we do that, let's talk about how we transport these views to the next environments. Let's say if you want, you have created few analytical views, attributes and calculation views. And if you want to move these views or transport these views to the quality, pre-prod and the production, right? Let's see how we can do that. So let's consider a scenario where, right, I have a dev environment, quality environment, and a production environment, right? In ABAP, when we create a report, we put inside a package, and then we'll add it to a tier, right? Similarly, when we want to transport the objects in HANA, we use an object or a special object called delivery unit. So delivery is like a package what we use to capture all these changes in terms of HANA. So the name itself is saying that it is the unit which helps us to do the delivery of the objects, whatever we are creating at the HANA layer. Right? This delivery unit helps us to transport the package along with the design time, right, inside to a quality and the productions respectively, right? So what do you think? So what we can include inside the delivery unit? So is it the runtime object which got created, or is the package along which the delivery unit we have created, right? So obviously we'll be transporting only the design time objects, and those are the objects which will be capturing it inside a delivery unit, right? So let's see how we can create a delivery unit. Okay, how we can create a delivery unit. So if you if you go here, click on window, right, and if you go to show view and click on others and check for quick view. Okay, select this particular quick view. Just select this view. It should have opened somewhere. Let me try to reset the view. Okay, yeah, to the bottom you can see, right? So just maximize this one. Okay, now you can see. So here, right? So this is where we can create a delivery unit. You can see at the top, right? Delivery units, create and manage delivery units. Now, what is mandatory to create a delivery unit? Right? So generally, we'll not be creating this. So let's say if you're working on a live environment or a live project, right? So generally, we'll not be doing this particular step. But I just want you to know how things needs to be maintained when you're ready to create a delivery unit. So these will be taken care by the admin section, right? So the precondition to create a delivery unit is to create a vendor assignment. The precondition to create a delivery unit is to create a vendor assignment. So that is actually done by the administrators, right? So how can or where can we see whether it got generated or not? Okay, let's see how we can check that. So let's see how, or let's see where we can see that. So just click on this HANA system, just double click. Say okay, go to the configuration tab. And here you should see something called vendor. Let me do a search here, vendor. Yeah, here if you see, so this field need to be there, right? You should see an entry in this particular vendor field. If you do not see that, right, and you cannot create a delivery unit. And this name can be anything. You can just create default, test, your project name, your system name. You can create this name with whatever you want. If the vendor is not there, you'll not be able to create a delivery unit in SAP HANA. That's the important part, okay? So as we now saw the prerequisites, now let's go and create a delivery unit. Let me maximize this again. And now I'll click on this. Select the system in which you want to create a delivery unit. And these are all the delivery units which are already created, right? So you can create your own one. Say create, we put some name, DL underscore Z batch underscore December 21, right? You can put all of the separate versions. Let's say if you are using it for the first time 1.2, you can put everything. Just say okay. Right? So here, once you select your delivery unit, in the below, you can see a button called add once again, right? So here it helps us to add our package in which you want to attach your delivery unit. So my package is ZBatch 21. I'll select my package and all the objects which are residing in my package will get added to this delivery unit. Okay, I'll say finish now. Good. So delivery units is created, right? Good. So now if you go back and again do the same thing, you should see the package, whatever you have created. Let me try to show you again. Go to delivery units, select here, say next. And this is the one which you have created, right? You can see version 1 and you can also see the package which you got assigned, right? Now what I'll do is, now I am ready with my delivery unit. So now I want to transport the changes or objects what I have created at the design time in development system to the quality. How can we do that, right? So again, I'll go to the quick view. If you scroll down, you can see something called export, right? Click on that export. Okay, click on the export and here go to SAP HANA content and select the delivery unit. And say next. Select the system. And here, in the drop down, select your delivery unit, whatever you have selected. So once you select that, whatever the packages which are involved or inserted into that will be selected here in the bottom here. Right? So here again, you can export to two locations. One is you can export to the server. The second one is you can export to the client. So I'll export to the client. I'll save it on my desktop just to show you guys, right? And I'll say next. You can see the day which is getting created, 20, 21, 12, 14, the current date following with the time along with the default naming convention of the package. Okay, I'll say next. Say finish. So once you do that, it says it is done. So if you go back to the desktop, you can see this is the delivery unit, what we have just exported from the development system. Right? Let's say you're done with the development, you have exported your delivery unit from the dev system. Now you want to import it to the QA system. How can we do that? Right? How can we do that? Let's see. Now suppose, consider this as you are in a QA system. Right here in the QA system, just open this and you need to click on import now. Instead of export, you need to click on import, delivery unit. Next. Here you can select either server or client. Because we have saved it on the desktop, I'll select client. I'll say browse. I'll select this zip file. And you can see all my objects which we have just attached inside our package is being displayed now. You can see the analytical one, the analytical views, the attribute views, and the calculation view. You can see all the status is good. If you click on finish, right? So all these objects will be now imported into your quality system. Okay. There are different sets here. So because based on the activation mode, you can use those modes. But the default mode is stop activation in case of any inconsistencies are seen in the affected object. So what if you see any inconsistencies between the objects, we generally select this option. We don't want to activate it, but ignoring the inconsistency. We want to fix it and then we want to activate it. Okay. Once you click on finish, all the objects will be imported into your QA system and you should be able to use them. Right? So is the delivery unit reusable? So let's say here I have created a delivery unit. Right? We just created a delivery unit, exported all the items and imported into the QA system. Now, if I want to use the same delivery system because I have done some changes in the development package, can I use it? Yes, we can use the same delivery unit any number of times. Right? But one thing you need to observe here is there is no automated version management for this particular aspect. Right? We don't have any version management which is automatically controlled. Right? Good. So now understand how we can transport these objects from one system to another system. Right? Now we'll see how. Okay, so before going to the next step, let's park it here because we have created information views, and we also saw how we can transport those informations to the next environments. So now the next step, what I want to show you guys is the S4 readiness, what I have talked about, right? Let's go back or jump back to the SAP system here. Completed the reading of information models on the top of HANA layer. We also saw how they are created, how we can consume one view inside another view, and we also saw how we can transport the design time objects, whatever we have created in the HANA layer, to the next environment. Right? Now we'll give a break at the HANA layer to come back to the ECC layer to discuss few things. Right? If you try to recall, I told that if you want to, or if you are working on a HANA DB migration projects, and if you want to ensure that no issues happen in terms of a custom code, what are the different tools we need to use? Right? We use mostly two important tools. One is the SCI, SAP Code Inspector, and the second one is the ATC, ABAP Text Cockpit. Right? So now we'll perform an analysis to check out DB migration stability in terms of code. Right? Now, okay, let's go to SCI. I'll just create a demo program so that we can see what I'm doing it here, or how we can do or use the SCI inside it. Okay. Quickly, let me try to create a sample program so that we can use this. I'll say this is our program. Just remember this program. Okay. So okay, since I don't have a package, let me create it so that we can save it whenever we need. Let me create a test package. This is created G test_batch1. Now let me try to create a report now. Okay, so let me simply write a quick program here. So I'm just writing a program just to show you guys how, if you have a custom program and if you are migrating your system from your traditional ERP to S/4HANA system, what are the different tools we need to use and how we can study the custom code and identify what are the different things or issues we may get and how we need to solve it. Okay. So just simply wrote a simple select statement here. Now what I'll do is I'll just try to read a read table. And I'll say with key char ID equal to LH, con ID equal to 0. Okay, and I'll say, because I know the data, I'm just putting it here. 20, 13, 0, 1, 0. I'm doing a binary search on this one. Again, I'm writing a select star from S. Yeah, this program may not look good, but I just want to show you what are the different things we will face when we are doing it. Okay, that's the reason why I'm writing this kind of a code. Right, and where char ID equal to LH and con ID equal to and now I'll write deleted some duplicates from that, comparing char ID Now I'll just do a loop. Okay, let me try to just save and activate and see if it is if I'm able to run it. Okay, it is activated. Okay, I'm just trying to see if I can get some data here. Okay, z test print rate. We don't have any data for this field. I'll just give some data. Just give me a second. Okay, 2/1/2016. Change the date. Okay, good. So we wrote some program, right? And what we want to do is now we just want to use this particular program, right, to investigate to see if we move this program to HANA, if are there any hard stops or issues, it will throw us back, and we definitely need to resolve before going to migrate to HANA, right? So now what I'll try to do is, now I'll go to the T code SCI. I'm going to T code SCI, right? Here I'm in the T code SCI, SAP Code Inspector, right? Now I'll create first an object set. So this is a standard process. So if you are migrating from a traditional ERP to S4 process, S4 HANA, and if you want to check in terms of the custom code analysis, these are the two tools which we use. And the first one which we use here is SCI. Once we enter this SCI, we need to create an object set first. Right? Let's do that. Click on this create button. Sorry, just give the name and say gtest underscore and underscore db check. Okay. Now I'll say create. I'm creating an object set first. Okay. Good. So these are all defaults. So what you need to do is just scroll down. Just scroll down. You'll something called free object choice. Right here, provide your object name. Here, provide the object name which we just created. Right. What is the object type? Because we wrote a program. Let's select the program. I think the PROG. Okay, it should be PROG only. Just PROG. It's a program, and just give the program name what you have created, which is just give this one and say enter. Right, program, and we just give the program name which we just created, and now click on save at the bottom. So it says it got saved. Come back. Okay, come back, and here now go to the check variant. Click on the check variant and say F4. If you see an F4, we can see a lot of variants here which SAP gave by default, right? Which SAP gave by default, right? So we'll use one which is functional check variant, what SAP has provided to us, right? Which we can use to do the functional checks in terms of the database layer. Okay, SAP gives us a standard variant called functional underscore DB. This variant is pre-labeled by SAP, right? If you click on this, right? If you click on the display icon, right? Just click on this display icon. You can see what are the different kinds of checks this particular variant is doing. So these are all the ones. If you just open this, it is doing a security check for the critical statements. Similarly, if you scroll down, in terms of robust programming, the guideline what we discussed, the best practice what we discussed, it is also searching if there are any DB operations on the pool or cluster tables. So if you find these kind of issues, it will not allow us to continue. It will give us a hard stop. Okay. This is the variant you need to use when you're doing a functional DB check. Good. So now we'll create a inspection. Let's just give an inspection name. I'll say Z test underscore DB underscore migration. Let's say we're doing a migration for the DB. Right. Now select create, and here, right, you need to select the object set whatever you have created. Say F4, and this is the one which we just created, and also check the variant what we discussed, functional underscore DB. Say F4, select the functional DB. So these are the two things which you need to select. The first one is the object selection, object set, and the check variant. Once you do this, click on save, right? It was saved successfully, right? What we did was first we created object set. After that, we saw the variant and understood what variant needs to be used. And after that, we created an inspection in which we have consumed the object set and the check variant. Right? Now click on execute at the top. If you observe, this will just check only the program which we just attached. What are the program we have attached? It will check only that program, right? In a more realistic scenario, if you are doing a migration project on SAP HANA, so you will have lots of custom programs. So your inspection tool will create or check all the custom programs, whatever you have brought in into that particular object set. Let it run. In the meanwhile, we'll try to open. We'll go to ATC. Okay, I'm just clicking on the T code ATC. This is the screen. What you'll see once you click on the T code ATC. The first and foremost of what you need to do is click on the schedule runs. Okay. Click on the schedule runs. Okay. Once you click on that, you'll be coming to this particular screen. Here, you need to create a schedule. Right? You need to create a schedule here. Okay, so just give the series name whatever you want. Let's say I'll put ZDB checks. I'll say ZDB checks is my series name. Right here, if you see, the description is auto-populated. So this gives us a clear understanding of, if you see the report, the first letters are being described by the system name, right? And the date of when it is run, and the year, and the corresponding week. So these are the different things, what it is considering it as a default when trying to create this particular series, right? So, okay. So here, if you scroll down again, right, you can select any type. So let's see if you want to create or run this ATC report on your entire package, you can do it, right? But if you also want to just run it only on an object, you can also only on the object set, you can do it. It depends on your use case. Okay. So what are the description you're seeing for this job will come with a system name, calendar week, and year, so that we can schedule any number of runs and leave them overnight, and these can run, and the next day morning we can see the result, right? So this is automated. So this is also a bit automated and beneficial in terms of using SCN compared to ATC. Okay. Let me see if that run got completed here. Okay, it's still going. Here also, if you want, I'll select the same object set, say F4. And also here, one more thing, the variant also you need to change. the one which we are using, you need to use the functional underscore star. This is the variant which you know, the same thing. So there is no difference here, but only it's like a process chain. The tools, the functional, everything is one and the same. So here, once you select that, scroll down, select the object set. What is the, I could not recall the object set. Let me go back. Z test and okay, Z test it is okay. Okay, just save this one. And once you save, you'll get this particular kind of a set here, right? So once you get this, right, if you just select this and say schedule, and you can just leave everything as it is. There is no need for us to check anything here, and simply say execute or execute in background. It all depends, because you can execute also this kind of ATC in background. So this is also one more benefit what we'll have with ATC. Okay. And here we'll have a couple of options, like if you want to say, yeah, if you have a multiple servers, right? So you can just change these notifications. And if you want to send a notification once this job is completed, all these things you can configure here. I'll just say execute. It's not picking this one. Let me check on this one. Or else I'll simply give the package here. Let me try with the cab package. G. So now I'll try to schedule and see if that takes. Yeah. Now if you see, it says check run successfully scheduled. So it means it has successfully scheduled a job. Now what I'll do is I'll just go back. Here I came to the ATC screen. And here you'll see something called runs. Yes, runs. So here we just schedule it. Here you can see something called monitor and control runs. Just double click. And it will take you to the new screen. Okay. Just say execute. You have a series called this one. And you can see the description is S4H, which is system name. Today's Tuesday. And it is the current week of 2021. It says, what is the state of this job? It is finished. It has run the series ZDB checks. And if there are any failures, it will show us. Okay. You can click on the result button here. If you click on this particular result button, you can see what are the different issues it has identified. If I just drag this, these are all the 3 priority 1 issues. That means you definitely need to fix these issues before migrating to S4HANA. If you do not do that, it will cause problems, or these reports may not run or may not perform as you are expecting in the migrated S4HANA system. And this is how it is identified. Okay, let me go back to SCA and see if that got finished. Okay, it seems it took the entire system package, did not consider our objects. That would have been taking time, but yeah, this is how the problems will be identified. Right? If you see once the SCA is completed, right? If you compare these results with SCI and ATC, you see the same results because both are almost one the same tools. But ATC has the really advantages, like it has few extra capabilities, like you can schedule it, you can do or run those scheduled jobs in the background, right? And we can do more iterations, right? And it's also integrated with transport organizer, just in case if you need it, right? All this can be easily done it via here, right? Good. And the same things, okay, let me check it afterwards. Right? This is how we generally do a performance, the functional DB validation when you're trying to do this migration from ERP to S4HANA. We can do that on HANA side as well. Let me go back to the ABAP perspective, right? And if I open the package here, the object what I have, okay, if you just open this program here, right, inside the ADT, we can call ADT or HANA Studio. Both are one the same. Just open it here. So few things here is when you're using this HANA Studio or ADT, right, ABAP Eclipse. If you see that it is not behaving as it expected, just restart this IDE. Still running anyways. And I'll show you how we can do the same. So whatever the things we have done in SAP GUI, like using ATC, SC and all that, the same things you can done in, or you can do inside this ADT as well. So whatever we have done out there in SAP GUI, the same thing you can do it here as well. Okay, so here you can edit the program, you can change the program, you can activate it, you can do everything. But let's say if you want to run the same ATC or SCA what we have ran or SAP GUI in here, just select the program, right click. If you go down, you can see ABAP test cockpit, ABAP unit test with, right? So these are the different things what we will get. Okay, so from here you can run the same things whatever we have just ran. Okay, so whatever the things we have run over there, you can do it. You can, let's say, ABAP test cockpit with here. Here you can just give the variant. So what is the variant we have used there? The function underscore db. Just type the F. Once you do that, you can see. Okay, let me try to bring it up. You can see the same errors what we saw or what we get inside that ATC. We got it here. Read binary search, delete adjacent duplicates, and loop it right up. If I go to the SAP screen, read binary search, delete adjacent duplicates, loop it right up. Okay, so there is no need for you to go back again to SAP GUI screen to do or run this ATC. You can do it from here itself. Because currently we are just working on two lanes, right? So the left side where we get all the object list, to the right side where or what we see the programs. We do not go the next steps where, because if you see here, just we executed this and we got a new tab here which is called problems view. So in this view we can see what all the problems we are getting. So we'll go one by one what all it contains. Okay, good. So anyways, we are here, right? So anyways, I thought of showing you how to fix this error from ADT only, right? So here, once you run the ATC test on a custom program, these are the errors which were identified, and you need to fix it to move it forward. So now let's see how we can fix this error, right? How we can fix this error and see how we can move it forward or go forward from there. So here the simple things our ATC gives us is it clearly tells us So there is a problematic statement for the select statement what you written, and it does not have any order by. That's what it is saying, right? So what are the issues what we get? We need to fix it from here. Okay, there are a few other things which we'll check. I just want to show you this one. And let's say if you really want to fix these issues, right? So because we got some issues and if you want to fix it. So let's see how we can fix those errors, right? So here it says loop at I tab and it says without order by. So most of the statements, whatever we are using, does not have the order by statements. But before I go there, I want to tell you on the new ABAP syntax. Okay, we'll do one thing. Once we'll complete this part, and then we'll work on the ABAP syntax so that it will be easy for you to understand on the next steps. Okay, so this is how we generally what we say run a ATC test or a SCA test to understand what are the different things or errors we may get, right? We may get and how we need to resolve them. Okay, so we'll try to address these issues in the next what you call in the next coming examples, because we focus around different criteria, like what are the different steps you also need to check if you want to improve the performance of a custom program, right? Because these errors I have just wrote just to show you guys how the ATC and SCA works, right? And once you get an error, how can you solve it? So what you can do here is, so if you just click on here, ADT has few other functions. Just click on it here. Okay, you can see something called quick fix. Just select that, and it will give you a hint. Right? It will give you a hint, like different options. You can use it or you can write it. So if I just say insert it, it will insert based on your recommendations. Right? It depends on how you want to fix your error. Right? Similarly, if you just scroll down, say quick fix, it gives us what you want it to do. Let's see if I say finish, it will add that particular statement over there. And that's how you can fix those errors. If they are pretty simple, it's straightforward, you can use this quick fixes. If not, you need to fix it on your own. Like you need to do the relevant changes based on the error what you get. Similarly, if you go here and if you just double click, whatever the error you are seeing it here, right? The same log. It's a priority one issue. This is a problematic statement for the selection here without order by, right? And it also tells you what you need to do. The same error message, you can see it here as well. If you just double click, sorry, if you just hit mouse over, you can see search for problematic statements for select or open cursor without order by, and it is in the red state. Right? That means you definitely need to fix these errors before going forward. Here, and once you fix these errors, and then if you run the same, we'll try to fix these 3 errors and then run the program and see what are the different errors it will give, or whether it will give any other priority 2 or 3 errors. Okay. So when you're doing a migration, priority 1 are the ones which you definitely need to fix. Without that, you will not be able to go forward. 2 and 3 are, it depends on your use cases. Let's see if your organization is okay and if you have ample amount of time for your developers to spend. In those cases only, we generally go for the priority 3 and 2. But first and foremost thing is we focus more on the priority 1 issues. Here are any questions? So I'll park this aside because I want to show you also what are the different things we need to understand in terms of new ABAP syntax. Because whatever the code fixes we'll be doing it using the ABAP new syntax, so that you'll also get a fair understanding of how we can write and use those things to fix the errors what we get in the custom programs what we have. Okay, take you back to a different thing here. So in the meanwhile, let it run because I want to show you in SCE also how it goes. The same error what you see in ATC in the ADT, the same errors only you'll see in the SEA as well. Good. So what SAP has done is with 7.4, SAP not only just introduced the connectivity to HANA, but it also has introduced a new syntaxes to ABAP. ABAP developers who has worked recently or previously on the reports, FMs, all those developers now are using this new syntax, new ABAP syntax from the 7.4, right? As I said earlier, it does not mean that the old syntax will not work on 7.4. It will work because with the usage of syntax, we'll get some performance enhancements or improvement what SAP HANA is providing to us by creating a sample programs and see what are the new syntaxes which SAP has given to us. Okay. I'll show you the new syntax. We'll just create a new program called new syntax. Say new syntax. Now what I'll try to do is I'll just simply write a program here. LT underscore BP type table of SNWD underscore BP type SNWD underscore BP. So I just created a internal table on the work area. Now I'll write a select statement on SNWD BPA. You see that we just got the results. Like we just displayed the BP ID and the company names, right? Let's say if we change this work area to WA1, right? If we change this WA to WA1, so you here until unless you do a activation or syntax check, you will not know that this does not exist, right? But whereas in ADT, it shows us the design time check as well. So let me do a refresh here. Yeah. So here, if you see here, so we have WA, right? So we don't have any issues. That's fine. If we just change to WA1.
All right, let's test your knowledge. Here's a question for you. What is the advantage of using ABAP on HANA compared to traditional ABAP? Option A, improved performance for analytical scenarios. Option B, enhanced security features. Option C, better integration with other programming languages. Option D, simplified development environment. Take a moment to think, and when you are ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck. Type the correct answer in the comment section. Hey there, ready to dive into the world of SAP ABAP programming and SAP ABAP on HANA? Our course is your ticket to mastering these crucial skills. Take it at your own pace right here on our platform. In this course, we'll unravel the mysteries of SAP ABAP. It's like having a super handy toolbox for planning and managing supplies, ensuring everything flows smoothly from production to delivery. We've got you covered from the basics to advanced techniques. Crafted by seasoned experts, this course is packed with knowledge you won't find anywhere else. Your instructors, top-notch pros with years of experience. They're here to guide you every step of the way and clear up any doubts you may have. But don't just take our word for it. Our students rave about how helpful this course is. People just like you have found immense value in what we offer. And the best part, it's incredibly affordable. This amazing opportunity to level up your skills won't break the bank. Ready to become an SAP ABAP wizard? Enroll now on our page. For more details, head over to ZaranTech's website.
See, if you see here, once I change to WA1, we are getting errors by default. The WA is unknown. So it's like it's also doing a ZaranTech check. Right? This ADT has a new feature in it. You can see, right? So if I just put WA1, straightforward is saying that it's doing a design check without an interpretation. It says WA does not exist. We just put your mouse pointer. It says the field WA is unknown, but there is a field with the similar name. So these are the different kinds of checks. ADT is also helping us, right? If you execute also, you get the same result what we just saw. Yeah, actually, this version does not seems to look stable, but yeah, you should get the result being displayed on here as well, right? I just clicked on F9 because you can see it on the console. What should generally happen is it should show you the same screen how we are seeing. Here it should work if I click on F8. It is not opening the screen, but it should show you like the screen, whatever we are seeing it here. Okay. So that's how this ADT brings it. So now we'll see how this new ABAP syntax works. Okay, let's see how this particular ABAP new syntax works. So now what I'll try to do is I'll just try to change the same program such that it supports the new syntax. Okay. I'll say now instead of instead of star, what I'll try to do is I'll try to instead of star here, I'll select the column names. So if you recall how we used to select the columns, we used to give a space, but here we'll use the comma separated values to give the column names. So this is one of the syntax change, right? So one important thing when using this new ABAP syntax for this comma separated values is if you are using comma separated column list, we must use something called the escaping of host variable. What is host, right? Host is one which is actually takes care of everything, right? So here in our case, we are selecting the values and putting it into a internal table called LT_BP. So this is like a host. It is actually putting all our values inside this LT_BP, right? What does this escaping of host mean, or escaping of host variable, right? We need to put a @ symbol before this variable name, right? So what I'll try to do is into say corresponding fields. Now, because I have used this call out separated values, I want to use the variable called @ before the comma separated value, so that we do this escape of variables, right? So we created an internal table called LT_BP, right? With the name of LT_BP, right? And here, if you see, okay, I think if we change to this one, it will be easy for you to understand. Let me change the name to so why we generally use this or SAP HANA is if you see here, okay, if you see here, we have a BP ID, which we are using as the variable as internal table. And also we have a column name as well. So just to tell or differentiate between the host name and other field names, we need to add the escaping variable so that system understands that this is a host. This is a host. So just take care of this one and treat it accordingly, right? So this is the change what we have. So in the new ABAP syntaxes, we use comma separated column list. We will not use spaces like which we used to use before. And if you are using a comma separated values, you need to use the escaping variables. Okay, now let me save and activate and run it. You see, we get the same result. right? Even if you use the old syntax or the new syntax, we get the same result. Right? That is what about a using of comma separated values in the column names and also using the escape character called @. Right? So now we'll use one more new syntax called inline declaration. Right? So here what I'll try to do is, so I will not declare my internal table. Okay? I have just declared my work area. Here what I'll try to do is, in the same query, I'll say, I'll add @data. Data. So the rest of the code remains the same. What I have done is I just removed the data declaration for the internal table, and I have used just before that particular variable into which I'm storing these values. Right? So here there is no need to declare that internal table. Right? SAP will make sure that the new declared internal table allows us or gives us the feasibility to create the same structure of what we are selecting. So whatever the columns you are selecting, only that particular structure will be created during runtime if you use this particular keyword, which we call it as a inline declarations. So this BP underscore ID internal table will now have only BP underscore ID and the column company underscore name, only two columns, as we are just doing a selection for two fields inside the query. Why SAP has got this? Definitely we need to have some benefits, right? So we have few benefits here. So earlier, if you declare an internal table, it used to take all the columns, right? If you declare like that, you can use begin and all. In that case, you just take only a few selected columns. But generally, if you use the old way, which we have just done before, it takes all the columns, right? And the second thing is, I removed a query, and the purpose of the data variable is not there, right? We generally forgot to remove the data declaration. Let's say I am not using the internal table anywhere after 1,000 lines of code. I will not remove that particular data declaration because somehow people tend to forget, right? Because of that, the program still consumes the memory, and obviously that will affect your performance. One table may not affect, but if there are multiple tables which I have just declared, and if you are not using it, but you did not remove from the declaration part, right? It obviously takes or consumes the memory, right? If I just save and activate it again, okay, I got those corresponding. So similarly, what you can do is you can also remove this one, and you can directly give the data at the rate here. So data of work area. So if you do this, so there is also one catch here. Let me tell you once this is activated. And if I execute this, you can see the same result. So one difference what we have done here is, so for the, we have added these @ symbols are applicable only when you're doing a select query. If you observe this particular program, I have used the work area, right? I have used the inbuilt declaration, but I did not use @ for this one. Why? Because @ or the skip variables we use only for the select queries.
Hey there, ready to dive into the world of SAP ABAP programming and SAP ABAP on HANA? Our course is your ticket to mastering these crucial skills. Take it at your own pace right here on our platform. In this course, we'll unravel the mysteries of SAP ABAP. It's like having a super handy toolbox for planning and managing supplies, ensuring everything flows smoothly from production to delivery. We've got you covered from the basics to advanced techniques. Crafted by seasoned experts, this course is packed with knowledge you won't find anywhere else. Your instructors, top-notch pros with years of experience. They're here to guide you every step of the way and clear up any doubts you may have. But don't just take our word for it. Our students rave about how helpful this course is. People just like you have found immense value in what we offer. And the best part, it's incredibly affordable. This amazing opportunity to level up your skills won't break the bank. Ready to become a SAP ABAP wizard? Enroll now on our page. For more details, head over to ZaranTech's website.